Okay. So let me do a sound check real quick. Okay. So in this stream, we're going to talk about Curve Optimizer, and I have been testing Curve Optimizer with two different CPUs, both of which I have done content on the channel so far, but I am not convinced that my PC is 100% stable with these settings. In fact, when I started to go live, the stream didn't actually start, and this is unlike previous streams. So this tells me that my system is not 100% stable with the settings that I'm currently using. I will show my settings here. We're going to go over this. We're going to talk about Curve Optimizer because that's kind of what the title of the stream is. But I'm not 100% sure what is what the absolute 24/7 100% stable settings are. And we're going to go over that. But everybody's CPU is different. The silicon lottery is a thing, so just know that setting Curve Optimizer, depending on how aggressive you go with the negative offset for the voltage curve, doesn't guarantee stability for every CPU. They're not all the same. So with that being said, I'm gonna go ahead and talk about the CPUs that I did. So I tested two different ones. One of them was the Ryzen 9 7950X, and the other one is the Ryzen 7 7700X. So I tested these two because these are the two that I have. So we have two different data points, two different CPUs. One was purchased at launch, so that's this one, and the other one was purchased around, the Black Friday, end of November, early December time frame. So that could have been a different batch. We also tested two different motherboards, but the only problem with the test that I did is the sample size is from the same vendor. So I used Gigabyte. X670E Oris Master for this one, and the BIOS that I tested Curve Optimizer with is the latest one, so it is a GISA 1004. I don't know if that introduces anything for stability wise. I think there's some memory. Hey, good evening, Joey. This is probably going to be a stream for you because this is going to be all about overclocking via Curve Optimizer. And basically, I've been doing things with Curve Optimizer offline, testing stability, and I've been trying to figure out kind of the ideal 24/7 stable settings with Curve Optimizer for my two Ryzen CPUs to see what I can actually do with better performance, or at the very least, similar performance at lower power, at much lower power and lower temperatures. So let me make sure so let me make sure this is still alive. Okay. So, actually, let me make sure I have the right BIOS. I'm going to give you guys the BIOS that I'm using, or the BIOS versions. So for those in the chat, or the viewers, this is on, let me go ahead and add this in here. This is BIOS F8H is the BIOS with a GISA 1004. So that's what I tested my Curve Optimizer settings with. What happened? During the middle of a Windows update, everything just froze and the drive probably corrupted like a solid 2 minutes ago. Are you using Curve Optimizer? Because I'll tell you guys, I am not convinced right now with the Curve Optimizer settings that I am currently using. I don't think my PC is 100% stable. And I'll go into the settings in a little bit, because when I started the stream, there was a weird thing where OBS froze and I didn't actually go live. So I had, and the monitors reset, and I had to close OBS and restart it, and I had to close Chrome and restart Chrome and go back into YouTube. So that has never happened to me before with any live stream. So that tells me that that is definitely my overclock is not 100% stable. So regardless of that, I'm still running it with the current overclock settings. We're going to see if we can get through this live stream with this overclock / undervolt, whatever you want to call it, using curve optimizer. But we're going to get into that here. So I tested that with the 7950X. And the other one you guys may have seen on the channel. So this is going to be the Aorus. The other motherboard is the Aorus Elite AX Revision 1, because there's actually 2 revisions, so I have the older one. And this one is going to be with a GISA 1003 patch D. I don't know what the difference between patch D and all the other ones are for 1003. All I know is that 1003 has been on, it's been out for basically since launch. I think at launch we got the 1003 patch literally on launch day, and that was supposed to help with the memory training, because the memory training took a very long time with all the older patches, especially 1001, which was on the launch BIOS. There was a question on the video that I did for the 7700X build. Somebody in the Premiere chat asked what was the BIOS that I was using on the Gigabyte Aorus Elite. So that BIOS, so when I built that computer and filmed that video, that was using the F5 BIOS. And I used that until recently. So today, currently, the Elite is on a different BIOS. I think it's on a beta BIOS. I'll have to look it up real quick. Let me find it. It's older than the one that is on the Aorus Master. But it's not that much older. I think it's definitely a GISA 1003. Okay, so it is F7F. That's the BIOS on this one that I tested, Curve Optimizer. I wanted to get 2 different sample sizes, at least 2 different AGISA codes. So I tested 1004, 1003. Now, granted, the CPUs are not the same, so there's a little bit of silicon lottery differences there. But for all intents and purposes, both of my CPUs, I want to say they perform very similar in terms of the sort of negative offset that I could get. So let me just kind of get into the settings here, and I'll just share that with you guys. So bear with me here. I'll just type them up. So I tested. So okay, if you guys have a Gigabyte BIOS and you updated to the AGISA 1004, they, at least on the Aorus Master, they introduced this new feature called performance. I kid you not, the word is Bung. I don't know why they chose this word, but performance Bung. They call, you know, if you Google the definition of this, it's basically like a washer, or like a, it's like a it's it was for like pipes or something. It's weird, but this is the name of the feature that Gigabyte added in the latest BIOS, Performance Bung. Essentially what it does, it contains a set of presets for Curve Optimizer. In Curve Optimizer, well, actually in PBO, I should say it's presets for PBO. So Precision Boost Overdrive, we already talked about this in a previous live stream, but just to reiterate, with Precision Boost Overdrive, you can essentially tell the CPU to either ignore the limits and boost higher. You know, you can supply a plus 100 megahertz or so, that sort of thing. Actually, let me go ahead and illustrate that a little bit. Let me bring up my other desktop. Hopefully it's still on. Where did it go? Oh, here it is. Okay, let's show this on screen. Let me bring this up. How do I bring this up? Okay. So this is my, let me bring the wireless keyboard over here. This is where wireless keyboards come in handy. So I'm controlling my other PC. So this, what you guys see on screen, this is the Gigabyte Aorus Elite AX motherboard. So this is the one that has the 7700X. You guys can see, does it say the CPU anywhere? Well, I guess not. Anyway, if we go to advanced CPU settings, and then you guys can see in here Precision Boost Overdrive, or PBO. You go in there, and then you can see in here, normally it would be under auto or enabled. I think it's auto. Auto is the default. But if you change it to advanced, you can either set limits, whether that be no limits, auto limits, basically disable the limits, or actually I think if you disable the limits, then I think it doesn't actually run. It's a little confusing. If you choose disable, it actually disables the limits. So it doesn't actually run. And then motherboard will be like Gigabyte's unlimited power mode, which could be problematic if you're trying to control temperature, so I don't recommend doing that. And then manual is kind of where you would go if you wanted to set eco mode. I've done a video on YouTube about this manual mode. So that's if you wanted to do power limiting or enable eco mode. Because from my experience using manual mode, the BIOS defaults are way higher than anything you'd want to specify if you're setting it to manual. So it tells you the CPU in basic view. Oh, okay. Let's go to basic view. Okay, so you guys can see. So we're running the Ryzen 7. So this is the F7A BIOS. Wait, F7A BIOS. Did I say F7F? I don't... Okay, so we're on F7A. That means that the beta BIOS that I updated to was replaced on Gigabyte's website by a newer one. That's what that is. But you can see here, like this is the... Oh, that's not the mouse. This is the other mouse. So here's the mouse. So you can see I've enabled the Expo profile. The cool thing is if you're someone who doesn't want to mess with the advanced menu, you can turn on the Expo profile or the XMP profile from the easy mode view. You can also see if the RAM is installed in the right slots or whatever, and then you can see like PCI. It gives you the ability to see PCIe devices or SATA drives, so that sort of thing. But for what we're going to be doing, most of what we're going to be doing is going to be in the advanced mode. So when you get out to, let's just start from this top here. So the default for this would essentially not have Expo enabled, so I basically turn on Expo. And the one thing I will say is at launch, someone left a comment asking me, not just the BIOS, but they were asking if the Expo worked. So when I purchased this motherboard from Micro Center, it shipped with the F5 BIOS, which is not the day one release BIOS. I think the release BIOS back in September was F2, if I'm not mistaken, and then some of them were F4, but this one shipped with F5. So this one, the memory training didn't take nearly as long as what I was used to with the launch BIOS. So enabling Expo profile there for the DDR5 6000, that was really easy to do. The one thing I will also note that for those of you that are having issues where you put the PC to sleep, like for example S3 sleep mode, which used to be called standby mode if you're talking Windows 7 or you know, Windows XP even. One thing that I noticed was sometimes the PC would not wake from sleep. When you like press a button on the keyboard to wake the computer up, it wouldn't wake up. That was something that I noticed at launch. Now, these newer BIOSes seem to have fixed that. And what was causing that was having the Expo or the XMP profile enabled. Because what I think was happening was while the computer was asleep, when you go to wake it up, I think there was a bug with the BIOS where it wasn't specifying the correct VDDQ voltage on resume. So meaning your DDR5 would wake up, but it would wake up at like 1.1 volts. And that's not a high enough voltage to clock to 6,000 megahertz stable on the RAM. I have seen this problem at 56 megahertz on my XMP RAM, and that sort of thing. So it seems like they've fixed the issue. But for those of you that still have the problem, what I suggest you do for that is go to DDR5 voltage control, and just over here where it says VDDQ mode, you want that to be synchronized. Synchronized means it will the voltage value that you specify will go to both memory sticks, or all memory sticks. Not just the A0, the A1, but also the B0, the B1. If you specify it asynchronous mode, then it will actually, like if we go here, well actually I think you got to do it from here. Yeah, if you do that, you get it off of auto and you program them to be asynchronous. You can specify different VDDQ or VDD voltages for your memory. I don't think that's a good idea. I don't recommend doing that. But for those of you, I know there's a number of people. I was looking at Reddit and I saw like on the /r/AMD, people were still complaining about their PCs not waking from sleep when they have the Expo or the XMP profile enabled. I think most of the motherboard manufacturers have resolved that issue. I know MSI, I think, seems to be the last one to push out that update. But I know ASRock had been on top of it early on. Gigabyte and Asus never disabled S3 when you turned on Expo, but the problem with them was that people would turn on Expo, run their RAM at like 6,000 megatransfers, put their computer to sleep at night, and then come back to it the next day, try to wake it up, and it wouldn't wake up, it would just hang, and they would have to basically cold reboot the machine to get it back. So the workaround, what I've noticed, is if you specify the VDDQ to the static voltage of either 1.25 volts or 1.35 volts, or if you're going for an extreme memory tuning, like for example 6400, you would specify like 1.4 volts or maybe even 1.43 volts. That does tend to fix that issue. Am I going to do any videos about overclocking? So this is basically going to be about overclocking. We're going to be talking about a curve optimizer. But I just kind of wanted to get this out of the way because I noticed that people were having this issue. I actually had this issue too back in October. I had to run my RAM at 5200 megahertz because at 5200 megahertz, that is within AMD's official speed. And at that slower speed, you never run into the problem with it not having enough voltage when it wakes up the RAM from sleep. So this is kind of the workaround. So go into VDDQ and set that to whatever your RAM's Expo profile is supposed to say. So in my case, this RAM requires 1.35 volts. So if you go back here, notice how in the Expo profile right here, it says 1.35 volts. That's the voltage number. So I took that number and I basically plugged that in right here for VDDQ. VDDQ is essentially, you can think of that as the same thing as the DRAM voltage from DDR4, because I know a lot of people that are upgrading to either Ryzen 7000, or if you guys went with the Intel 13th gen, you would have run into the same problem, or even like last year with Alder Lake, like the early adopters for 12th gen Intel would have run into this problem, not knowing exactly what is the DRAM voltage parameter, because it doesn't say DRAM voltage like it used to. It's got all this other stuff like VDD and VDDQ and that sort of thing. You just ordered the ORS Master. Cool. I mean, I think it's a solid motherboard, especially if you want to add like USB 4 and you're like not 100% sold on Thunderbolt. You have the option to add Thunderbolt to the ORS Master. Whereas like if you went with the Crosshair, you'd have to pay like $200 more for the Asus Crosshair, but that would include the USB 4. But the nice thing about the Gigabyte Master is that it does give you more freedom with the PCIe slots off the chipset. So that's why I kind of like this one more than the Crosshair. So that's going to be it for the DRAM. That's going to be the overclocking for the RAM. Because you guys have to remember, like, Expo is considered an overclock. Anything above 5200 megahertz on the RAM is technically an overclock. So it is not a 100% guarantee that you can run your RAM at 6000 and be 100% stable. So that is something that you are going to have to tweak and tune to try to get the right numbers. Or I guess to get 100% stability. So that's going to be it for that for right now. What I'll show you here before we go back to the settings is I want to show you guys, like in the Gigabyte board, you go to Advanced CPU Settings, and then under Precision Boost Overdrive, this is where most of the overclocking is going to take place. It's almost always going to be done under Precision Boost Overdrive. Now, on a previous live stream, I did talk about OC mode and the pros and cons of using OC mode, but I think for the average user, the person who wants to use their PC as their daily driver and they want to extract a little bit more performance out of the hardware, they're not going to want to use OC mode. You're really going to want to use Precision Boost Overdrive for the overclock. So in this case, what I've done is I've gone under here, and what you can do is you can specify a thermal throttle control. So I have set that to 80. This is going to be 80 Celsius. Now you guys can set this to, for example, 90 Celsius, or you can specify this to 70 or whatever. So, but what I will say about the performance Bung, they call it performance Bung. It's a ridiculous name, but Gigabyte added that recently. What it does is it essentially allocates a specific thermal throttle limit to a specific curve optimizer negative offset. So for example, if we say 90 Celsius is the thermal throttle limit, the CPU, instead of going to 95C, which is the default, it will go up to 90C, and then that's where it'll level off the 5 point whatever gigahertz that it can hit. Now you can further optimize that using curve optimizer over here, and what we want to do is we want to do all core negative, and then you want to try to step it up in increments of 10. So what this number here is, the 20 indicates this is actually a negative 20. So this is a negative 20 offset to the curve optimizer. So if you think about well, I guess I should probably draw it out because then it'll probably be easier for people to understand. So I'll probably need to switch back over to the paint file here. So let me do that. So every CPU has a voltage frequency curve. So we'll just say it looks something like that. Meaning for every point of, well, we can say voltage and temperature, but we'll just say, how do I want to draw this out? I guess I'll say this is the temperature, and then up here, the y-axis will be the voltage. We'll just draw it out that way. It can be either way. You can flip them and you'll see a similar result. Meaning for a specific, well, I guess I should say not temperature. We should probably do this frequency. Yeah, not temperature. The reason why temperature does come into play is because with these new Ryzen chips, for some reason, AMD decided to base the boost algorithm based off of the operating temperature rather than the actual frequency. You use individual cores for curve optimizer. That is definitely further fine-tuning, but that will take a lot more time. In my opinion, that's good. That is actually the best way to get the absolute performance, but that is a lot more time-consuming to figure out like which cores are the really good cores. Because sometimes for me, core 0 seems like it's the best core, but oftentimes I've also seen like core number 3 has done really good. And then for my Ryzen 7 CPU, core 7 is like probably the best one. So it takes a lot more time to figure out which cores are the better ones. But that's definitely the way to further optimize it. So basically what this is saying is for a specific frequency, like for example, if we say this is going to be 3 gigahertz, right? 3 gigahertz, then 4 gigahertz, and then we'll say 5 gigahertz, and then 6 gigahertz up here. So as the frequency goes up, you'll need more voltage. Actually, I probably should have drawn this a little bit different because it tends to be a little bit less linear. It becomes more exponential, actually. So as the frequency goes up, so here we're pushing 5.5, and then as you get up to 6 and then beyond, the amount of voltage needed goes up significantly. And as voltage goes up, temperatures also go up. So what Curve Optimizer does is it essentially says, if I apply negative offset, so if this is my default voltage tier, if I say negative offset, basically it's saying try to follow along this curve with with less power, meaning try to use less voltage to try and hit the same frequency. Meaning, like, for example, if we're doing 5.5, like right here, the -10 or -20 offset means that I only need that much voltage as opposed to this higher amount of voltage to hit that same exact 5.5 gigahertz. I hope that makes sense for everybody. So you leave a lot of performance on the table if you can use all-core. Yeah, all-core is definitely the quick and dirty way. Like, that's kind of what we're showing here. But yeah, per core is definitely the way to go if you want to invest a lot more time into fine-tuning the processor and trying to figure out like what's the ideal overclock or the ideal operating frequency per core on a per core basis as opposed to an all-core basis. Because realistically, out of the box, if you're just playing games, like, stock performance is actually really, really good. What we're really trying to tune here is more so the maximum performance when you load up all the cores. Because what ends up happening is, you know, you've all seen the reviews, the 95 degrees Celsius operating temperature, that ends up being the barrier. And then what has been shown is that even with liquid cooling, the amount of headroom you get by adding liquid cooling doesn't actually allow you to clock the processor that much higher compared to just a giant air cooler. So you really have to go with some either super exotic like dry ice or some advanced cooling, which isn't really practical for everyday use. So really, the name of the game here with the curve optimizer is to try to lower the amount of power and lower the amount of voltage used to maintain while maintaining the same exact frequency that you get out of the box. That's kind of the idea. And if you're lucky, if you have like a golden chip and you won the Silicon Lottery, then you'll actually extract better performance, because with less voltage and with a lower operating temperature, you end up actually allowing the CPU to clock higher. Because when the CPU is running cooler, there's less current leakage surrounding the transistors. So it gets into semiconductor device physics at that point. I'm not really going to go into that detail, but basically, the higher the temperature, the more voltage, is required. So that's the reason why lower temps is always better. And that's the reason why this performance bung, as what Gigabyte calls it, is actually a pretty interesting feature. So what this does is it says if you want to you specify a temperature. So in this case, 90 Celsius would be level 1, which equals -10 offset on curve optimizer. Likewise, you can also do a level 2, which would be a -20 offset in curve optimizer. And you can actually do this all the way down. I don't know if this is like all the way down to -50, but I'll tell you guys, I tested this new feature from the Gigabyte motherboard. So this new Agisa 1004 BIOS from Gigabyte on the Aorus Master allows you to simply select from these levels. So you can do level 1 all the way down to level 5. And you can specify the temperature. So I'll go over my exact settings. I don't think you should copy my settings, but if you want to try and see if your CPU can do the same that mine can do, feel free to try that. So this is the first subset, but it also allows you to do 80 Celsius. And here's where I think it gets really interesting. Hey Joel, this stream is going to be all about overclocking. So what I have found is 80C actually is way more well behaved in terms of the frequency, the voltage frequency curve when you run it at 80C. So 80C level 1, I'll give you guys the numbers in a little bit for my own testing, but I really recommend that you guys try the 80C level 1 or the 80C level 2. And I'll give you guys some specific numbers. I did Cinebench runs to see like how the behavior is different. But essentially you can go all the way down to level 5. Now, what I tested a couple of extreme conditions. So I tested the stock power limits with PBO. I tested 90C level 1, 2. I tested 80C level 1, level 2. And then I also turned on eco mode. So I basically made the processor run at the 105 watt TDP as opposed to the 170 watt TDP. And then I actually was able to go all the way down to level 4. I was actually able to go all the way to a negative 40 offset with 80C as the thermal limit. Now, the thing is, when I was at negative 40, I don't think my processor was 100% stable, but I was able to do a Cinebench run, and the performance was quite surprising, because it was actually running like 38,000, and it was only running at 67 degrees. So it's a really interesting feature that Gigabyte added. It's basically, you can select from a list. There's the 90C options, there's the 80C options, levels 1 through 5. And there's also the 70C options, levels 1 through 5. So this is perfect for those of you who don't really want the processor to ever go to 95C. What I'm using right now is this one in particular. So I'm actually running my processor with an 80C level 2. So that means it's going to be a negative 20 on the curve optimizer offset. And on top of that, I have also specified a plus 100 megahertz boost, max boost beyond the limit boost. So what does that mean? Let me go back to the BIOS here to show you guys what that actually means. So in here, you guys will see, here's the 20. So this is the negative 20 that was on that screen earlier. And then, okay, so this is supposed to be 80. So let me change that back, because I was using 80. And then what I've also done is right here, see where it says CPU boost clock override? So you can enable this either positive or negative. If you do positive, it means that you're going to add, and this value is in megahertz. So in this case, I want a positive number. I want plus 100 megahertz to the maximum CPU boost clock. It tells you right there at the bottom. It says, you know, increases the maximum CPU frequency that may be automatically achieved by the precision boost 2 algorithm. So this is essentially how you hit 5.8, 5.9, and maybe possibly, if you won the Silicon Lottery, 6 gigahertz. Not all core, but like max precision boost. So with these settings on the Ryzen 9 7950X, I'm able to get 5.8. It's like 5.8. Let me see, do I have it up right now? Yeah, so let me share. Let me switch this back over. Is it up? There we go. So here's my hardware monitor, so you guys can see. So right here, you can see like the maximum. See that 5.8? That's 5,842 megahertz on Core 0. Here's 5850. So that's 5.85 gigahertz right there on those top two cores. So with this plus 100 offset, I'm able to get, 5.8 gigahertz on lightly threaded loads. So I guess the key takeaway here is what you can do with this feature where it says, max CPU boost clock override. Think of this as more of like for single-threaded, lightly threaded applications, or certain scenarios where it's lightly threaded and the temperature is low. You can add a certain amount of clock speed to the maximum boost. So this is in increments of 100. Well, okay, here it is. So you can start off slow, like 25, plus 25, plus 50, plus 75, plus 100. You can go all the way up to plus 200 if you wanted. Now, I did plus 25, and then I just went straight to plus 100. So now I haven't fully tested my CPU, so, who knows? I could maybe do 5.9 if I do, 200. But this is just kind of for illustrative purposes, so you guys get an idea of how the overclocking works. So the cool thing about this is that this extra megahertz boosts the max boost at lightly thread. So this is going to influence things like single-threaded performance. Whereas the the lower temp, like the 80 Celsius max with the curve optimizer with that negative offset, is going to influence the maximum full core, all core performance. So you're going to get lower temperatures while either performing the same in highly threaded workloads, like for example, in my case, DaVinci Resolve. Obviously, Cinebench runs will be improved. If not, the score will stay the same as stock, but it'll be way cooler in terms of the temperature, since we are going to limit this thing down to 80 Celsius. So that's kind of the key takeaway there on how you can use Precision Boost Overdrive to tune the processor to get a higher, lightly threaded frequency, and also a better performing, lower temperature running max core, full core performance. So that's kind of the takeaway there from my own testing. I've tested both. Now what I'll do is I'll just kind of show you guys like specifics in terms of how the two processors that I tested actually behaved. So let me bring back up this again. So in my case, oh, and for those wondering, I tried level 5. Level 5 for me was no post. So my CPU couldn't do 80 Celsius, with a negative 50 offset. It didn't work. So like I wouldn't even be able to boot into Windows. What would happen is it would post, and then it would get to the point where it's like Oris, and then you see the circle starts spinning for loading Windows, and it would literally like hard freeze while loading Windows. So that shows you that Curve Optimizer is not going to be a guaranteed 100% stable scenario. So in my case, I can't do level 5 at 80 Celsius. I didn't try 90 level 5, so I don't know if my processor can do this. I highly doubt it, because if it can't do it at the lower temperature, it's not going to be able to do it at the higher temperature. I'm pretty sure, because the higher the temperature, the harder it is to maintain stability. So you have the 5700X overclocked at 4.7, all core with temps of only around 70, running Cinebench R23. Yeah, that's kind of the benefit. That's the whole idea, right? The lower temperature. Did you know that you can use your Intel to decode AV1? You can use to decode AV1 to stream 8K videos? Oh, you mean, yeah. Actually, I kind of think you can, technically, can't you decode AV1 with the CPU? It'll just be slower, like it'll load up the cores. Yeah, I know in YouTube you can specify the settings, like you can specify your playback settings to always prefer AV1. But the thing is, you can also do that with the RTX 30 series and the Radeon 6000 series, because they both of those GPU families also supported AV1 decode. Yeah. Yeah, no, I knew it had AV1 decode, because AV1 decode, that wasn't the new thing. It was really the AV1 encode was the big selling point when Intel was marketing the whole ARC story initially. But then, everyone else kind of followed suit with, Ada GPUs having that, and then the new RDNA 3 GPUs also featuring that. So now they're all basically the same. Okay, so let me show you guys. What I'll do is I'll just kind of tell you my Cinebench results. So here's what I was able to do. So stock, and this is going to be the 7950X. Stock Cinebench for me was 157. So this was my stock Cinebench score. So with Curve Optimizer, with 80 level 1, I'm getting 36,927. So you guys have to remember this one. So this stock, these are Cinebench scores for those wondering. So what I'll do is I'll just make it like a table. This is R23. And then I'll tell you guys the temperature. So that's the temperature. We'll fill that out. We'll fill out the V core. So that's the voltage, and then the curve offset, and then the power draw. So you guys can get an idea of the benefits of doing Curve Optimizer. Because I've been putting this off for a while. The main reason why I didn't really do much with Curve Optimizer until now was because I was just wanting the platform to mature a little bit. Kind of like with Intel Arc. I'm waiting for Intel to basically... I still want an actual control panel. I don't like that overlay that they use. But kind of like the same thing. I'm waiting for that to bake in the oven more before I do more content on Arc. But so, same... Now, revisiting Ryzen 7000, so these Agisa updates have been great because now the memory training happens way faster. You know, it can wake from sleep properly while Expo is at 6,000 mega transfers. So that's really good to see because now you don't have to worry about memory stability anymore. So now you can dive into actual core overclocking, undervolting, and using the Curve Optimizer feature. So that's really good to see. So, and then we'll just kind of go in here. So the temperature at stock, we already know, is 95C. The V-core at stock was 1.41, I believe. Or maybe it was 1. No, that's the like absolute. It's like 1.37. So then the curve offset is nothing at stock, and the power draw at stock is 200. It's roughly 230 watts. And then if you do 80 Celsius level 1, obviously the temperature is only going to be 80 Celsius. The V-core at level 1 for me was 1.2 volts. The curve offset is -10 on the Curve Optimizer, and the power draw. Here's the thing: the power draw drops to 197. So you're basically dropping 30 watts of power and 15 degrees. But you are losing some performance. If you notice here, the level 1, you're losing what, like 1,200 points there in terms of your Cinebench score. But realistically, you know, that's about 37,000. That's still a really good score. That still beats everything except a stock 7950X and a stock 13900K. And obviously, you know, like all the big Threadripper 5000, the Threadripper Pros will basically beat all of these, but that's kind of outside the scope of this content. So level 2. So here with level 2 is where it starts getting interesting. So here I scored 37,372. And for those wondering, I did 3 Cinebench runs, and I averaged the score from 3 runs. That's kind of where I got these numbers. I didn't just do 1 run and just call it a day. So I wanted to heat it up a bit and then like average the runs. So this is again 80C, and the V core here is 1.212. So what's interesting is in this case, I don't know, this is kind of within margin of error. But I did use a little bit more power, which is kind of weird. At least the V-core read a slightly higher number, even though we're applying a -20 offset with Curve Optimizer. So that was kind of weird. But the score went up, which is strange. You know, it's sort of within margin of error, but not really. I mean, this is what, 372. This is about 400 points higher, with less power overall. So here we're at 175 watts. You've hit 43,000 something? Yeah, and that was with OC mode, wasn't it? That's using OC mode. See, the thing with OC mode is more for like world record sort of thing or extreme overclock. OC mode is not really something that I would recommend as a daily driver, 24/7, you know, daily use scenario. But yeah. Level 3, did I test level 3? Oh, okay, so my level 3 numbers are kind of weird because oh wait, yeah, I did test it, and the power is actually lower, so that's really interesting. But the score's not higher. So we got 1.104 is the volts, and then here we're at -30 on the offset, And the power draw is down to like 143 or 145. We'll just call it 145 so it's the whole number. Yeah, you mixed the two or something like that. But you notice, like, doing these tests, you can kind of see, like, the name of the game is to try to get as close to, if not equal to, or maybe a little bit better if you're lucky and you win the Silicon Lottery, than the stock. That's the whole idea. Because now you're lowering the power consumption. That means you're also going to lower the heat. You're going to lower the operating temperature and all that other stuff. So that's the whole name of the game. So these are my own 7950X. I'll show you guys like 7700X as well to show you what a single CCD. So level 4, I got 3750. Now this one to me was questionable because the temperature didn't make sense. So here the temperature was actually way down. So this to me is an example of what some people in the overclocking community refer to as clock stretching or frequency stretching. Because this score looks really, really good, you know, at roughly 70 degrees. But the thing is, I don't think this was 100% stable. I wouldn't feel comfortable running my computer or trying to, like, do specific tasks for productivity with this sort of curve offset. I think it's too low. The interesting thing was the power consumption didn't really change. I was still reading around 145. But the temps were quite a bit lower. But I don't think that there was enough voltage being fed to the cores. It was just kind of giving me this number, even though I don't think it was stable. Like, I wouldn't feel comfortable recommending that people just go in, set it to level 4, set a negative 40 offset on Curve Optimizer, and call it a day. Because I think that the higher the level, the better the CPU bin has to be to achieve that. So in my case, when I did level 5, and I think I said this earlier, couldn't get into Windows. So this was kind of the limit. So in my mind, my chip either maxes out. It can do level 4. It can do a negative 40 offset, and capping the temperature to 80 Celsius. But I don't think it's stable because the behavior that I witnessed didn't really seem like it was stable. Like, the power draw was still kind of the same as negative 30. The voltage was higher. Like, I was reading a higher voltage at less power with a, you know, it just didn't make much sense to me. So this to me is an example of clock stretching or an unstable overclock just waiting to crash. Like, I think if I wanted to prove that out, I would have to load up like Final Fantasy 14 and then try to, like, queue up for a raid or something, and then have it crash on me while I'm in the middle of the raid. And that's a really bad situation. So that's a no-go. To reach over 40K at only 177 watts of power draw and 75. So yeah, see, that's a golden sample. Yeah, that's a golden sample. But see, that's the sort of thing, like, if you can do level 5 at 80C, so his is 75C, that means he's basically using, like, the 80 temperature limit, or maybe the 70 temperature limit. No, 70 temperature limit. It won't go over 70. But yeah, that's actually really good. Because if you can do over 40K at that temperature, that's a golden sample. That's basically the golden chip right there. That's a Silicon Lottery winner. That's what it looks like. But you guys can see this is what mine can do. I would say, for 24/7 operation, I would say this is probably what I would aim for. The 80C max, level 2. So it's, you know, it's a little bit worse than stock, but it doesn't go above 80 Celsius at full. Remember, when I say 80 Celsius, this is at maximum load. This is like doing an R23 run, and it doesn't go above 80 Celsius while doing Cinebench runs. So, or like Prime 95 or those sort of things. So that's with a negative 20, and the power draw is down to 175 versus like 230. So that I would call that pretty good. I would say this is a pretty decent CPU. Not all CPUs can do level 2 from what I've heard. In some extreme rare cases, some CPUs can't do level 1. So those are the real duds out there. But that's supposed to be a really, really small number from what I've heard. Like, I mean, I've talked with some of the other overclockers in the overclocking community, and they've told me that they've seen some CPUs that can't do level 1. Level 1 is a -10. So if you can't do a -10, you have to do like a -5 or a -7 or maybe a -9. And, you know, that's just an unfortunate, you know, that's a loss of Silicon Lottery right there. But I would say a good 90-something% of CPUs should be able to do level 1. And then I don't know what the percentages are going to be, but I would guess maybe 2/3, if not 70%, 75% maybe can do level 2. And then, you know, maybe a smaller number, maybe almost 40% can do level 3. And then I think that's kind of where it levels out. Then if you try to go to level 4, that's where it gets a lot harder. And then level 5 is really just the winners. But that was me testing it with an 80 Celsius cap on the temperature. Now, you could also test the same thing with 90 Celsius. So, in terms of 90 Celsius, let me try to think. I guess with 90 Celsius, I tested 2 levels. So, for me, let's make this larger, I guess. So for 90, I tested level 1 and level 2. I didn't bother to test level 3 on 90, but I'll go ahead and give you guys my numbers. So for 90 level 1, I did 36,958, and that's 90 Celsius, and that resulted in 1.248 volts. Offset is -10. Power draw is 226. So when I did 90 level 2, I got 37,854. So I actually got a pretty good result there. And it was 90 Celsius. It didn't go over 90. And it was 1.26 volts. -20. And the power was 222. So not too much of a difference there in terms of the power draw. But the score was quite a bit higher than level 1. So, but this kind of shows you, this right here is a good example of how using less power or less voltage, you can actually get a higher amount of performance out of the chip, which is kind of interesting when you think about it. I mean, it's really weird because if you guys did overclocking in previous generations, like if we go way back to like Intel Haswell or maybe AMD FX, overclocking back then was not like this at all. Like this to me feels like overclocking graphics cards, because graphics cards overclock a lot like this. Like if you overclock using EVGA Precision X on NVIDIA, or if you're overclocking using Radeon settings on AMD, or even just Afterburner for either Radeon or GeForce, the way it works is kind of like how you overclock Ryzen. So it's really, really strange how the way AMD has designed Ryzen over the last couple of generations. I want to say since Zen, maybe Zen 1. Zen 1 did have OC mode, but Zen 1 didn't. No, Zen 1 didn't have Precision Boost Overdrive. So yeah, I guess it was whenever Precision Boost Overdrive, which I think it launched with Zen 2, which would have been Ryzen 3000. I think that's when it started, where they started overclocking like this, where I guess it became harder to get more performance. It's almost like they just literally give you all the performance out of the box, but then now you have to try to tune it to either get better thermals at the same performance numbers, or better performance numbers with lower power if you win the Silicon Lottery. It's really strange. Like, this is kind of what overclocking has become. And then Intel's an even more interesting Intel. So overclocking on Intel, it used to be very old school, but I've looked into it recently. I'll probably do a video on Intel as well, on the 13900K, because that chip is really intriguing, because all those E-cores are such a waste of space, and when you turn them off, the thermals actually improve dramatically on that thing when you're at full load, which is really, really interesting observation. But that's something for another video. C0 only gets -30. Oh, we got a new sub. I should probably wear my headphones so I can actually hear the notifications. Thanks for the sub. Negative 30, negative 35. Wait, C0 did. What do you mean by C0? Oh, curve optimizer. Curve optimizer. Did the BIOS update allow? You know, I don't know. I assume it did, because this new feature allows the negative 40. So level 4 I know is negative 40. Because I wasn't stable at level 5, I couldn't verify what the setting was for level 5. So I don't know if it trails off. Like maybe level 4 is negative 35 or negative 40, and then maybe level 5 is like negative 45 or something like that. I don't know, because I wasn't stable at those levels, so I wasn't able to verify it. You got The Witcher 3 for $10 on Steam to test. But this is what I've noticed though, like, I really like the 80 Celsius thermal on this, because if you can do negative 20 and 80, and if your chip is better than mine, you'll probably be scoring like 38,000 plus, or maybe even 39,000. I don't know. If it's better than mine, you might as well just do negative 30 offset, and it'll probably score even higher. So, but that's kind of the name of the game with Curve Optimizer. Or you could do like what Joey was suggesting and do like, I guess the real way to tune this further would be to do a per core optimization, where you basically figure out like what's the fastest core, tune that one, give that one a plus megahertz offset, kind of like what I showed earlier. And because what I did was I did the plus 100, right? But you might be able to do plus 150 or plus 200, and then you'll be getting, 5.9 or maybe even 6 gigahertz, or very close to 6 gigahertz on your best core, or maybe your best 2 cores. Because I think typically with Ryzen, I've seen usually there's 2 or 3 really good cores, and they're usually in the same CCD. And then if you have like a single CCD, like the 7700X, which I did also test. I didn't test it as much, but I tested that CPU, and I'll probably show those numbers as well. Let me just kind of delete this, and then we'll kind of put those on the board for people to see. But when I tested the 7700X, so that one I did 2 tests. I did 90 level 1 plus 100 megahertz, and I got a score of 19,851. And that's going to be negative 20 offset. Or no, that's going to be... Oh, no. Okay. I misspoke there. It's level 2. So it's negative 20. So that's a negative 20 offset. And the power draw was only 115 watts or so. So that was the Ryzen 7 7700X. And then I did the same test, but I capped the temperature at 80 Celsius with the plus 100 megahertz. And I got 19,633. So within margin of error. But the nice thing about this was that now we're running roughly at 100 watts, and it's 10 degrees cooler. So 10 degrees cooler, and you guys keep in mind that all of these overclock settings, all these results that you're seeing are with air cooling. I'm not doing anything with liquid. This is all with an NHD 15 cooler. So the cooler that I'm using, you guys have seen it in like my videos, Noctua NHD 15. All of this is done with nothing more than an air cooler. So, I can get it to run no higher than 80 Celsius and still score, almost 20K on Cinebench with an 8-core Ryzen 7 7700X. So that's pretty good. So that kind of brings it back in line with the efficiency that you saw on Zen 3. Because what I've found is the efficiency on the new AM5 CPUs, they are actually more efficient than the older Zen 3. It's just... what AMD did was they did this whole, ramp it up to 95C no matter what, and then that's what makes the power draw go way up. But if you either run it in eco mode, if you mess with curve optimizer like what I'm showing here, then it actually becomes more efficient than Zen 3 while outperforming it by a lot. Not if you buy the 8K, or not if you buy the Deep Cool. The deep cool is basically the same thing, but it's like way cheap. It's like half the price. Per core. Actually, R360 AIOs only $100. You could even do individual cores in C0 core optimizer, but just have all CCD1 like -25 and all the CCD2 -20 or so. Yeah, you could do that too. Hey, Oak, is Arctic Freezer? So is the 360 really $100? NHD 15 is supposed to be like $100. Now I know with the way everything is, like the price of it has gone up. We talked about it in a previous stream. But typically, the Noctua is supposed to retail for around $100. Then if you buy the Chromax Black one, then it's like $110. Yeah. Yeah, the 360... So 360 AIO should yield better... A little bit better than the NHD 15. But I would say... So the NHD 15 is basically like a 280. Like a 280 millimeter radiator, for those wondering. Without the water. And without the pretty lights. But the thing is, so you guys saw my build video, well, if you watched the video. So for those wondering, I did, right before the end of the year, I did a build video featuring the Ryzen 7 7700X. One comment that I got a couple of times on that video was, what is the cooler that I'm using? So I tend to forget that it's actually not a D15. It's actually an NHD 14, for those wondering, which is the predecessor to the D15, but it's essentially the same thing. The only difference is the D15 has better RAM compatibility because they made the front end of the first heatsink stack slightly higher up, so that the RAM, like, you can basically put taller RAM underneath it without it obstructing it. Whereas the D14 didn't really get along with really, really tall, like Corsair Dominator RAM, for example, that wouldn't fit underneath a D14. So that's the main difference between the two of them. But I have had my D14 probably for maybe, I want to say like 8 years. Maybe 9 years since it's 2023 now. So almost 9 years with the D14. And it still works like the same way it's always worked. And I've never had any problems with it. So, like, try running an AIO for almost a decade and see if you can get that kind of mileage out of it. Without water slowly permeating through the tubes over the years. So, it's, you know, like, I'm a big air cooler person for that reason. You know, like, I can reuse this cooler with every CPU generation. I not have to worry about it. Yeah, but these are the results that I got for the 8-core. I didn't do too much testing with the 8-core. I do need to tune it a little bit more. But yeah, that's kind of what I got. So, you know, 100 watts, 80 Celsius operating temp at full 100% load. So all 16 threads are loaded. Plus 100 megahertz, so for lightly threaded. Basically, the way this thing works, for those wondering, this will kick in when the CPU is under 50, I think it's under 50 or maybe it's under 60. It's either 50 degrees Celsius or 60 degrees Celsius. So if it's under one of those two, I think it's 50. If it's less than 50 degrees Celsius, you will get an extra 100 megahertz boost. So it's definitely a lightly threaded thing. And that's the reason why I definitely like PBO overclocking more than like OC mode. Because you still get the benefit of the downclocking and the power savings, because you're not running it at a static voltage. So you do get a lot of that efficiency gains with PBO enabled. So that's basically it. I will do more testing with my curve optimizer settings. I might do like what Joey was suggesting. I might actually try to tune per core, or I might actually try to tune per CCD, and I may do a follow-up on that. But I don't know. Right now, I'm not 100% convinced that my CPU is 100% stable. I might need to try to either remove my plus 100 megahertz max boost, or I need to back the curve optimizer down a little bit and then see if it's stable. Or I might need to raise the temp max to like 90 again. Arctic Freezer's good. Yeah, like people have asked me about liquid cooling. If I was gonna go liquid cooling, I would get a 360 millimeter. I wouldn't get anything smaller than a 360, because the NHD15 is basically equal to all the ones that are just less than a 360. So like a 280. I would never get a 240 or a 280. Those are not worth it. So let me see. Is there anything else that I wanted to cover here? Because I think that's pretty much it for curve optimizer. I mean, the per core is something. Per core overclocking mode or OC mode, but we don't really do that on this channel. There is something called the Precision Boost Overdrive Scaler, but I don't really think that's necessary. I think realistically, the only tools that you really need if you want to fine-tune the processor is it's going to be all in Precision Boost Overdrive. So it's going to be Curve Optimizer, and it's going to be the thermal throttle limit if you want to specify a thermal throttle limit. Now, I personally like the thermal throttle limit being at 80, but if you do specify in 90, you could even do 85. It's not like these are fixed values. The only reason why you see me listing like this level 1, level 2, level 3, that's because I'm basing the terminology off of Gigabyte's new BIOS feature that they added with the new AGISA 1004 update. I think Asus has a similar name. I don't know what it's called, though. I forget the name. The name escapes me, but I know Asus has that on their BIOS as well. I don't know what the one on MSI is called. I definitely don't know the one on ASRock. But so far, I will say that the Gigabyte motherboards have been pretty solid in terms of stability as well as the performance. I'm waiting for another YouTube channel, probably Harper Unboxed, but I'm waiting for one of the bigger YouTube channels to start reviewing the motherboards. I want to see motherboard comparisons, because at launch, the Aorus Master was one of the fastest motherboards. Like, hands down, especially in gaming. I don't know what it was, but for some reason, Aorus Master was always like a chart topper at release. Like with the old AGISA 1001. I don't know what happened after 1001. I know that, like with 1003, I don't know if it was patch A or patch C, but there was one of the patches on the 1003 reduced how aggressive the boost algorithm on Precision Boost Overdrive worked. So I don't know if they plan to restore that back to the way it was at the launch BIOS, or if they're just going to keep it that way. They might do that. I think the only reason why they would do that is for stability reasons. So it introduces more stability. But the key takeaway with these newer BIOS revisions is that you get better memory support for one thing. The other thing too is the sleep bug is fixed, I think. So far I haven't run into it, and I've been running my RAM at the full 6,000 megahertz and I haven't had any problems yet. So that's really good. That's probably the biggest reason alone to upgrade to these newer BIOS revisions. And then I guess the other thing too is just general support stability for different add-in cards, like PCIe cards and that sort of thing. Because those take time to validate from the vendor. So like Gigabyte, for example, they have to test whatever they can get. Either like a vendor like AverMedia or Elgato has to send them the card, and then their debug team or their BIOS team has to test it, and they have to verify that it works. Because oftentimes what I've seen with product launches, like especially when there's a new socket like this, certain things don't work. Like, I'll give you an example. Like last year when Intel's 12th gen launched, I remember installing my AverMedia 4K capture card into the Z690 motherboard, and then I downloaded the Rec Central software for AverMedia, and they're like, oh, there's a firmware update. Do you want to update the firmware? So I click yes, not thinking anything could go possibly wrong. And then you know what ends up happening? It says failed to update, and then it's like the card is no longer detected. It basically, somehow my capture card got bricked. It just straight up got bricked from, I don't know what caused it. So then what did I end up doing? I opened up a support ticket with AverMedia, and they're like, well, we might need to do an RMA. So then I was like, okay. And then before I did any RMA, I took the capture card out. I plugged it into my old AMD Ryzen 5800X PC, which used to be the main PC. I plugged into that, and then Rec Central detects the card with firmware version 0000, basically nothing, and then it reflashes the card, and it's worked ever since. So I had to use a Ryzen AM3 mature motherboard, so an X570 motherboard, to resurrect and save my AverMedia 4K capture card after it got bricked from a Z690 Intel motherboard. So I assume that BIOS updates for compatibility fixed that issue on Z690 at some point. But that's an example of something being an early adopter and then like running into these sort of things. And then with Ryzen, so with the AM5, the only issue like that I've run into is, again, with AverMedia. Sometimes when the computer goes to sleep and I wake it up, the capture card doesn't wake up with the PC. So I'd be forced to reboot the PC to redetect the capture card. Now, the way I've worked around that is I basically added Thunderbolt to the motherboard, and I use an external Thunderbolt-based 4K 60 capture card. So if it doesn't wake up with the PC, I just unplug the Thunderbolt cable and plug it back in, and it just wakes up the capture card. So that's kind of the workaround. But I have been testing my capture card on the Gigabyte Aorus Elite, and so far with this motherboard, I have not run into that issue. I have yet to see it once not wake up with the Aorus Elite motherboard. So that's really interesting. I don't know why there's a difference, because I feel like they're both Gigabyte, so why would the Master not wake up the capture card, but the Elite can? That's kind of weird. Intel had a software that overclocked your CPU for you. You can still reinstall it. Yeah, I don't know if that'll work on the 13th gen, because the thing is with Intel, so Intel overclocking on Intel is very, very different than it used to be a few years ago. When I said that Intel's overclocking is old school, there's two ways to overclock Intel. So Intel has something called legacy adaptive voltage, and then they have like the newer one. It's called selection or selective or something like that, and it's completely different. So that's if I have to do an overclocking guide on Intel, it's gonna be, I have to like learn the whole thing from scratch, because I'm way out of the loop when it comes to overclocking on Intel's new CPUs. I know that the E-cores have their own. You can specify a frequency for the P-cores and the E-cores. They have two separate ones in the BIOS. But other than that, like the fact that they have adaptive voltage, I don't know if the adaptive voltage is for all the types of cores or just one of the cores and not the others. It's really weird. Easy OC with 360 millimeter. Auto setting and raising megahertz to 6,000. CPU Z reads that. All core. Yeah, I mean, the other thing too is you could turn off the integrated graphics and see if that helps. Because that does, when you turn off the integrated graphics, you are reducing the amount of heat on the die, because those silicon components, basically they clock all the way down to nothing. So it's like they don't draw power. You just use the Intel program to overclock the thing. See, I don't like software applications to overclock. Like, I know Intel has something, I don't know what it's called, and then AMD has the Ryzen Master. I have not used Ryzen Master since like the days of Threadripper, the Threadripper 2950X. Like, the only time I ever used Ryzen Master was with the 2950X, and that was a toggle between game mode and creator mode was what they used to call it, which was basically the difference between uniform memory and non-uniform memory. So basically NUMA and UMA. So the 2950X had it was a 16 core, but it had 2 actual dies. And this was before they had the IO die. Because remember, Threadripper, like the 2950X was based off of Zen Plus. So this is like first gen Ryzen. But that was the only time I ever used a software app. Like I personally will do everything in the BIOS. I'll stay away from software overclocking tools. That's why I don't like... I really wish, aside from like BIOS modding, graphics cards, I don't like using the tools to overclock graphics cards. So that's why I rarely ever, if ever now, overclock graphics cards. Because I never liked having to use Precision X. I definitely didn't like using Afterburner. I never liked using Afterburner. The only thing I would use Afterburner for now would be like to set up Rivatuner's overlay. To read out like the frequency and temperature and stuff like that. But yeah, for overclocking, no. I've never liked Afterburner, although it's pretty good. I will admit that it's probably the best one. And then for AMD, like Radeon settings, the only thing I would ever do with that is turn off 0 RPM mode for the fans. That's basically all I would do. Have I ever flashed? Yes, I've flashed VBIOSes for AMD cards. I've never flashed a BIOS for an NVIDIA card before, but I have flashed for AMD multiple times. You have to use a program called ATI WinFlash. I have no idea what you would use for an NVIDIA GPU. You have the 10700K overclocked to 5.1. The last time I overclocked an Intel processor was my 4770K. And that was I did 1.256 volts. And I got 4.4 gigahertz all core on it. But I could never run the DDR3 RAM above 1600 megahertz if I wanted to overclock it. If I wanted to run faster DDR3, like DDR3 2133 for instance, I would have to remove my overclock. So I ended up just running RAM at like 1600 megahertz and 4.4 all core with the i7 basically until I got Ryzen. NV Flash is the name. Yeah, I have no idea how to use it. I don't know. I'm pretty sure the commands are similar. But ATI WinFlash, so for me, I have flashed Vega 64 a couple of times. So like I flashed a secondary BIOS onto my Vega 64. I think I've also flashed a Radeon 7. Okay, so Radeon 7, I had to flash Radeon 7 because AMD launched Radeon 7 without a UEFI BIOS. They launched it with a legacy BIOS. And so you basically had to flash the one that allowed you to turn off CSM. Hey Cal, you were able to get a score of 20,313 with 7700X with PBO limits disabled. So when you do PBO limits, so when you disable the PBO limit, does that mean that it turns off PBO? Negative 30 curve all core. That curve optimizer is part of PBO. On a Asus Strix. Because in my case, like, I can't get... Well, hold on. I don't know what I pressed to like cause this thing to... Oh, did I press... Go to favorites page. Add, remove item from favorites list. What did I do? I did something in my BIOS. Hold on. Did I press insert by mistake or something? Oh, okay. I accidentally pressed insert to add things to my favorites list. I didn't want to be on there. Okay. So you did negative 30. So negative 30 is level 3. That's the level 3. Is what negative 30 is. If we're using the Gigabyte terminology. That's really good. That means that you got a really good... You got an above average binned CPU. Both times. If you're able to do negative 30... Because negative 30 is not something that every CPU can do. I think less than 50% of all the CPUs can do negative 30 and be 100% stable. I mean, I was able to do negative 40, but I don't think it was stable. I mean, otherwise I wouldn't be able to give you guys this score. Because I did negative 30, or I did negative 40 at 80 Celsius, and it got this score, but I saw weird behavior. Like, the power consumption wasn't different from negative 30. The temperature did not actually ramp to 80. I don't know what was going on with that one. And it felt like... It felt a little bit sluggish. So I think what was going on was it wasn't getting enough voltage, and it was doing something called clock stretching, meaning it's not 100% stable. The other thing too is you can try using eco mode. You can do eco mode and apply curve offset, but you basically have to be an absolute silicon winner to be able to get better numbers with eco mode turned on with a curve offset of negative like 10 or negative 20. But that is something that I will probably look into further. I did actually do that a couple times. In fact, I do have some numbers that show that. So let me see. I'm just looking through my notes. So when I did eco mode, I managed to score at 80 Celsius with eco mode. I scored 36,666. Oh, actually, no. Yeah, that's what I got. And it only pulls 145 watts. Yeah, I mean, I would check, but the thing is, I'm streaming from the PC, so I can't like go in and look. But I think it does. I don't know if it's specific to Gigabyte only, though, because I know that with... Because, see, like, this one here... So, this PC that we were looking at earlier. So, this one that you see on screen, this is not the latest BIOS. This is the Agisa 1003, because this is my 7700X system. So, this one is using the Gigabyte Aorus Elite, which is not on the Agisa 1004. Now, I could update it to Agisa 1004, and I think it will add it. But I do think that the most disappointing thing about Gigabyte, and I don't think it's just Gigabyte that's guilty here. I think it's basically all of the motherboard manufacturers. The documentation on these, the release notes for the documentation on what is actually changed with these new BIOS updates is, it leaves a lot to be desired. I'll put it that way. Like, for example, with Gigabyte, they never even said, so, like, if we go back to the, well, let me see if I can bring this up here. They never even told you that they added that feature, which is a thing that's super annoying. Like, if I pull up their BIOS download page, how do I share that? Oh wait, that's way too big. What happened? This is why XSplit is sometimes better than OBS. Because OBS does weird things sometimes. Okay. So, like, for example, right before the new year, they released F8H with a GISA 1004, which is the BIOS that I've been referring to basically the whole live stream. So this one introduced that level 1 through level 5 easy preset list for curve optimizer. This was not in the previous BIOS. But the thing is, nowhere in the description does it tell you that they added that ability to do that. Like, nowhere in here does it say. All it says is that it updated the GISA and, you know, improved memory compatibility. And then it has this useless checksum. You know, like, why is this the #1 thing to list on the description of the BIOS update? Like, you know, if it was me, I would put this at the very bottom. Like, this would be number 3 on the list. This would be number 1 on the list. I don't know who is writing the release notes, but they really need to do a better job, because this is really terrible. And it's not like I'm picking on Gigabyte, because if you go look at Asus or any of the others, it's not any better with any of the others. You have to, the fact that you have to go and waste time looking at Reddit posts or, you know, support forums for Asus, ROG, or some other, like, ASRock message board or something to try to figure out, like, what was actually changed, and then hope that some developer or someone that works for one of those companies replies. You know, that's kind of ridiculous. Like, I was running, so I went from F8B. I never actually went to F8C, and I regret not going to F8C because I feel like F8C actually fixed a whole bunch of things just by looking at this. The only thing, so what's funny here is number 7, improve memory and PCIe device compatibility. This is the thing where they supposedly fixed the issue that I had been seeing with the capture card not waking up from sleep. When they say PCIe device compatibility, there's actually a post on, I think, the Oris Reddit page where instead of saying this, it literally says fixed AverMedia capture card issue. So it's so poorly documented. It's really irritating sometimes to try to figure out what goes where and what was added and what was changed. Like, this is decent, but like this, the fact that they added a whole new feature to the BIOS and didn't mention it at all in the description, unless it's an AMD thing, which I highly doubt, because the BIOS, like, Gigabyte still has to validate the specific features on the motherboard before they actually make it public, so they should know what was actually added. And they use different terminology than Asus. Asus added the feature too, but they call it something else. So it's kind of laughable, but it's also kind of annoying to deal with that. Like, when you're trying to figure out, okay, is curve optimizer better? Is it worse? Is there a performance regression? Because regressions are another thing too that I'm always I always err on the side of caution when it comes to updating the BIOS. Like, I prefer not to update the BIOS on a motherboard unless there's some revolutionary thing that makes it so much better. Now, because this platform is so new, typically when there's a new BIOS, I would usually update to the BIOS. Like, in the case of, like, F8C, I didn't update to this. I skipped this one because I looked at it and I'm like, oh, it's still a GISA 1003. So, you know, that's, who cares, right? Like, nothing's different. Like, all this other stuff, who cares? Added ECC DIMM. I guess if you want to run ECC memory, but I'm not running ECC memory. Fixed the RTX 4090 PCIe down speed issue. There was a SMU for that. So, like, you know, apparently that was a thing. Actually, now that I think about it, I remember Jay's 2 cents did a video about that. So, I mean, that was fixed in this one. So, okay, good on that. but apparently it was fixed in this one also. So the fact that it was fixed in this, and this is a GISA 1001H, and this is actually pre-release, which is weird because this is before Ryzen launched, and this is before the 4090 launched. So clearly this was something that someone was testing internally before the products were even available for sale. The fact that this is publicly listed here is kind of hilarious, and yet there's a new feature on this one and they don't even talk about it. You use the Optimum Tech Ryzen 5000 video as a guide. Yeah, actually, so overclocking Zen 4 isn't really any different from Zen 3. The only difference between Ryzen 5000 and Ryzen 7000 is really the way that the processor behaves when it comes to temperature. So with the Ryzen 5000 series, those CPUs were power limited. With Ryzen 7000, they are temperature limited. That's the major difference. But in terms of how overclocking works, it's still exactly the same. They both have curve optimizer, so they both have like a set voltage frequency curve. So your negative or your positive offsets work, and you know everything else kind of carries over from Zen 3 to Zen 4. Because I think in the Gigabyte BIOS, the Gigabyte BIOS does say, you know, level... No, okay, maybe it's not in the Gigabyte BIOS. But I remember reading from Gigabyte somewhere, I think it was on a Reddit post for the X670E, they were saying something like, not all CPUs can do level 4 and level 5. And I think somebody said most CPUs should be able to do level 1 and level 2, which makes sense because level 1 is negative 10, level 2 is negative 20. And if you want to further tune it, like for example, if you can't get negative 20 to be stable, you can try negative 18 or something, or negative 15. Yeah, the only thing that I kind of wish I would have done differently was, I don't know, thinking back to the 7700X, I feel like I probably should have chose a different brand of motherboard. I probably should not have chose another Gigabyte motherboard. I don't know why, but it's like every time I go to Micro Center, they either, like in the case where I wanted the Meg Ace, I couldn't get one for the longest time. Then by the time it was available, it was too late because, you know, I had already spent the money on the Aorus Master, and I had already moved on because I was going to buy, like, Intel Arc, and then the other stuff that was coming out around that time. So I never ended up getting the actual motherboard that I wanted. And then the thing is, when I went and got the 7700X to replace the 5800X for the test system, they didn't have the B650 motherboards that I wanted. So I ended up getting that X670 board instead. That's the only reason why I ended up with that motherboard. Because you guys know I covered a lot of these motherboards. So I know from my own analysis which ones are better than others. And in my case, I really wanted a B650E, either the Asus Strix or the Aorus Master B650E, interestingly enough. But I ended up getting the X670, the non-E. Which is the one that I really kind of said not to get. But the thing is, it was relatively affordable. And at that point, at the end of the year, I don't really have that much money to spend on these motherboards anymore. So it's not like I'm going to go and buy another $500 motherboard. So it's like, yeah, I had to go with a budget motherboard. And the Aorus Elite was actually surprisingly affordable. You know, at like $260 or something when I got it. And then Micro Center gives you $20 off. So, you know, it ends up being cheaper. So... and the free RAM, so it's like I didn't have to buy DDR5, and you know I get the motherboard at a discounted rate. So that's why I don't know. I feel like it's really good if you're near a Micro Center, and you're a tech enthusiast. They always seem to come through when you are kind of looking for specific things. Yeah, but these are basically, they overclock very similar. Like in my case, I can do -20 on both. I haven't tested -30 on the single CCD CPU, so basically the 7700X. I do need to test that one. But in terms of platform overall, like, I feel like AM5 at launch, well, so AM5 today, it's a lot better than it was at launch, but even at launch, it was better than AM4 when it was new. The only problem is I feel like for people who are not that familiar with building computers and they go and build, like if they choose to build AM5 as their very first PC build, the only thing that I feel like, well, I don't know, 'cause some people might not have, if someone is building a brand new computer for the first time and they've never done it before, the fact that AM5 takes longer than average to train memory might not be an issue. Maybe I'm overthinking it. So, yeah, we'll see. I don't know. Yeah, the Micro Center card is another thing too. So in my case, I'll probably do the Micro Center card thing like the next time I plan to do like a big purchase. That makes sense for me. But that, yeah, I could have done it I could have done it last year, honestly, like with the either the AM5 launch or the Intel 13th gen launch. Either one of those. I mean, I feel like, what was the most expensive thing that I bought from Micro Center? It was probably the Red Devil. But that was just the one Red Devil item by itself. Like, with the AM5 upgrade, I got the motherboard and the CPU. And then with Intel, again, it was the motherboard and the CPU, which was a mistake. I should have never bought that Intel motherboard. But that's okay, because the Intel motherboard has a 10 gigabit LAN. I don't plan to do anything in terms of upgrading Intel this year. So for those wondering, like Intel, so because people have been mentioning Raptor Lake refresh, what do I think about it? So here's what I think is going to happen. This kind of is a good segue into product releases for 2023 and kind of my expectations for the year. So tomorrow, for those wondering, tomorrow at 6:30 p.m. Pacific time, so that would be like 8:30 Central or 9:30 p.m. So almost 24 hours from now, AMD's CES press conference will be live. So again, 8:30 p.m. Central, 6:30 p.m. Pacific. I suspect AMD might reveal the X3D, but I don't know if they will. So, like, I won't be disappointed if they don't show off the AM5 based X3D CPU, but if they do show it off, I wouldn't be surprised, because I kind of think we're now just over 3 months since Ryzen 7000 launched. So I feel like if they want to show it off tomorrow, am I going to stream it? I don't know. Like, do I need to stream it? I mean, do you guys want to watch my reaction to it or something? I mean, I guess I could. All right, Joey. Yep. I think, so here's what I think is going to happen. For 2023, we're definitely going to get a Ryzen 7 7800X3D. Like, this, I know for a fact, is going to launch this year. Now, the only question is when. Now, for those of you that are still on AM4 and you're holding out for this, my guess is that this is going to be at the earliest. Now, I could be completely wrong. I'm not the type of guy who has any insider knowledge. I don't have any leaked info. But I'm just guessing off of their normal release window. I would guess at the earliest this would be April or May. Like, realistically, I think it's going to be May. So that's kind of when I think the X3D will show up. Now, Intel will have the i9 13900KS. So they're touting this as a 6 gigahertz processor. This is literally nothing more. So those who are not familiar with Intel's KS naming scheme, this is literally a top binned i9 13900K. That's all this is. So it's literally a golden chip. This is a guaranteed golden chip Intel Core i9 13900K. That's all this is. So it's like if you want to pay $700 or whatever this is going to cost. I'm just going off of like the 12900KS was $700. So I'm just assuming that this will be the exact same price. This will probably be first. In all honesty, I kind of think this is going to be either maybe February or maybe March. I don't know. But I kind of think we're going to see the Intel KS first. And then AMD will come second. But regardless of which one of these launches first, I think this one's going to be faster. Because if you guys look at how much of a difference the 5800X3D makes versus like a 5800X, you can kind of extrapolate the percentage gains for what this will look like versus a 7700X. So the fact that a 7700X is the fastest gaming CPU that AMD currently has. So I'll repeat that for those that aren't paying attention. The Ryzen 7 7700X is currently the fastest AMD gaming CPU. It is not the 7950X. The 7700X is more consistent in the average game compared to the dual CCD Ryzen 9. This is a fact. Go look it up. Go look up the reviews if you don't believe me. But the Ryzen 7, which is cheaper, is actually faster than the Ryzen 9. So this is the reason why I chose this CPU to be the game test bench CPU to benchmark GPUs, because this one will be less likely to bottleneck the GPU if you're benchmarking for graphics performance as opposed to this one. And then I'm ruling out like any kind of weird, by not using Intel, because people are probably going to ask, well, why don't you use the 13900K? The answer to that is that CPU is way better for productivity than it is for gaming in terms of like cost per frame. And the other reason is because I'm on Windows 10 and the E-cores do absolutely nothing for Windows 10. In fact, in some cases, I have seen performance regressions using E-cores. I know this because I have seen it on the 12700K that I used prior to upgrading to the 1300K. So that is the reason why this is the most consistent gaming CPU, not the Ryzen 9 and not the Intel i9. But having said all of that, this upcoming AMD 3D part will most likely be the fastest gaming CPU. Now, I think in some cases, because Intel does have a compiler advantage, and when I say compiler advantage, what that means is if games are developed using Intel-based compilers for x86 code, they tend to naturally give Intel an advantage. Now, AMD is an x86 architecture, it's a processor, or the Ryzen processor, so you would think that it's the same, but not always, because especially if you have a dual CCD, it's a little bit different. So the E-cores have a similar disadvantage, just like the dual CCD Ryzen CPUs. So the fact that the KS clocks so high, though, is probably what's going to make it be a really good rival for the 7800X 3D. So these are the two big CPUs of this year in terms of the mainstream consumer desktop. You gotta be awake at 4:30 a.m. for the CES announcement. Well, that's pretty brutal. If you want to watch it live, I mean, I don't know when Intel's one is. NVIDIA's one was today. NVIDIA's one happened like earlier, and NVIDIA's one, man. What's the guy's name? Jeff Fisher. Jeff Fisher did it again. He did it again. You would think that he would have learned when he was criticized heavily by the tech press for his use of the word tie. when he referred to the NVIDIA RTX cards. But, you know, he did it again when he revealed the 4070 Ti. He literally called it RTX 4070 Ti. He just defied convention and just stuck to his guns and just called it the RTX 4070 Ti. So you gotta respect it. You gotta respect it. But other than NVIDIA's showing off the 4070 Ti and comparing it to the 3090, which strangely enough, he referred to the 3090 Ti as the 3090 Ti. So he actually said 4070 Ti and 3070 Ti in the exact same sentence. That just made me have to pause that live stream and think about that for a second. But you know, other than the 4070 Ti, they didn't really show a whole lot of anything interesting. Other than the fact that it's the MSRP is what, like $799? Yeah, $799. So that was the big reveal that everybody already knew about. So it's basically a 3090 Ti that uses way less electricity, according to him. So we'll see. Like, obviously, reviewers will test those claims. I expect it, on average, to be slightly faster in most modern games than the 3090 Ti. But in some cases, I do think the 3090 Ti will be better. 3090 Ti, first of all, it has way better amounts of memory. You know, 24 gigs versus 12. So for productivity, you know, I do kind of think 3090 Ti is still probably, in some cases, more optimal. But it from a cost perspective, it absolutely doesn't make any sense. It's definitely been out of the market for a number of weeks now. You can't even get one anymore. So it's kind of irrelevant. But I don't know. Like, they're really pushing the Ada architecture now in full force, especially with the laptop announcement. The claims with the laptops felt very misleading. I really don't think anything changed with the laptops. Like, yeah, they basically went through the typical motions of, you know, like, this is what's coming this year in mobile. You know, nothing really, very, very standard, kind of like in line with everything they've done with previous years. You know, like, you'd expect them, yeah, they're going to upgrade the laptops to the 40 series. You know, that's pretty much the natural progression for them. So nothing really out of the ordinary. Like, I'm trying to think. Nothing really stood out to me besides the fact that he called the 4070 Ti the 4070 Ti. I don't know, man. I might actually start calling those GPUs Ti. I might start using that naming convention instead of Ti. It's kind of catchy. I don't know. If I feature the 3080 Ti in another video or the 3090 Ti in another video, who knows? I might start calling them that name. But yeah, like, if you guys are expecting me to cover 4070 Ti, I'm not going to cover 4070 Ti. There's no reason to. I think all the big, like, Halo products launched last year. So, you know, on the AMD side, obviously the XTX and the XT, those launched. So anything that comes out this year are going to be weaker than those GPUs. They did claim 3x power efficiency in the laptops and call the 3070 mobile a flagship. Yeah, the thing that NVIDIA did that they always do that is always kind of like I don't think it's like scummy or anything, but like they showed a chart that had these. I remember they showed like these three for mobile, and then he said starting at $999. So when he says starting at $999, he literally means the laptop that has the 3060. That's every time they say starting at, and then they give you a list, it's always the weakest one. So that doesn't seem like great value. These never actually performed that good in laptops, to be honest. The power consumption was just too high. Like, I really thought that the previous... I even think, like, the 1660 Ti was probably, in my mind, the best GPU to get for a mobile laptop. Like, if you couldn't find, like, the AMD 660M or maybe the what was it, the 670-100M, like, I think these two were the best in terms of the price. Like, a laptop that was priced with a 660 Ti was typically, you know, like $700, six something on sale. That's actually really good value. And then the 6700M, the AMD one, like, those were way cheaper than the 3070 laptops. But they were actually a little bit faster because the 3070 mobile was nowhere near close to an actual 3070. So I don't cover too much mobile, but when I do release videos on laptops, they tend to get a lot of views. I don't know. I feel like the average person that looks at technology videos probably not a PC DIY enthusiast, and they probably are looking more at like mobile. That would explain why, you know, Dave Lee and like all these other YouTubers that do mobile product reviews probably have like massive audiences. There were leaked 3D Mark scores of the 4070 Ti. Oh yeah, I think so. Oh, there was a comment that came in, but it got held for some reason. So I saw Taylor put a comment in. I don't know why it got withheld. But there was a comment about M1 Pro. So the thing I'll say about M1 Pro, yes, I know the M1 Pro. I'm well aware of how good the M1 Pro is. The only problem is we're talking about, like, we're usually talking about gaming, and gaming on Apple is never really, you know, it's not really the golden standard. I'll just put it that way. But yeah, for mobility, and honestly, I don't really put a whole lot into a gaming laptop. Like, I don't typically buy gaming laptops, so I'll agree that the M1 Pro is really, really good. Because for me, like, honestly, if I'm looking for a laptop, I don't care too much about the gamer graphics card in the laptop. I'm more concerned with battery life, power efficiency, the fan noise, how heavy it is, you know, that sort of thing. And Apple does a really good job with that. So that's why typically I buy like a business class laptop. Like if I'm going with a Windows PC, it's going to be a ThinkPad with a Ryzen mobile processor, because the Ryzen mobile processors have amazing battery life for a Windows-based laptop. So that's why I did that video review on the... Well, you guys saw it. I have it right here in front of me. But that's why I did the ThinkPad review recently, like last... I think it was in November, maybe? Or maybe it was December. No, I think it was in November. But I did recently cover the ThinkPad, because this is not a gaming laptop. But the AMD 6000 series mobile processor makes this thing get all-day battery life while performing as good as like a consumer desktop from a year ago. So, but I think, okay, so going back to what we were talking about. So we're talking about laptops, but I think moving on, the other big products that I think are coming out. Now, obviously, we mentioned 4070 Ti, but I don't really think anybody really cares about that. There's the Radeon RX 7800 XT. This GPU, and I don't know what they're going to call the other one. So there's either going to be this and the 7800. These are going to come out soon. I'm guessing March-April timeframe. I don't know. I don't think they're going to announce anything tomorrow in the GPU space. I could be completely wrong, but I do think that at CES, AMD tends to talk more about their CPUs, so I do kind of expect this to be talked about tomorrow. I won't be disappointed if they don't talk about it, but it has to be soon, because I know a lot of people have been asking AMD about it. And the other thing is, we're now, like, Zen 4 has been out for a quarter now, for more than 3 months. So we're kind of at that point where it's like, okay, when is the 3D stuff coming? And then for Intel, we already know what they're doing. Now, real quick on Intel, people were asking me about Raptor Lake Refresh. So Raptor Lake Refresh is that's going to be late in the second half of the year. And that's not really going to be anything different from what we have now. So I won't really be covering Raptor Lake Refresh. I don't really think there's anything there worth talking about. So yeah, they'll work in the same motherboards. But that's going to be it. I think Intel's next architecture is going to be a lot more interesting. So Meteor Lake. But Meteor Lake is probably 2024. And Meteor Lake is going to be on a new socket and a brand new motherboard. So the thing about Meteor Lake is Meteor Lake will be the first Intel CPU architecture that will be fully exclusive to DDR5. So DDR4 will no longer be a thing with Intel's next generation, just like how AMD moved on to DDR5 with the Ryzen 7000 series. So Intel's going to do the same thing next year. But I do think that there isn't really going to be a whole lot to talk about for Intel releases this year. For those who follow Intel, I mean, other than like the KS, but that's kind of a meme processor. And then there's really nothing else there. Like, I don't think there's going to be any GPUs. So it's just going to be ARC holding them over basically throughout the entire year. Intel will probably put something out in the enterprise world. Like, they'll probably launch a workstation type graphics card, which will never really make it to the consumer market. And it might just be for servers. Who knows? Like the server blade. And then that'll be Intel. So that's Intel for the year in a nutshell. So AMD will have some interesting stuff. You know, the 3D. There might be a Threadripper. Now, the thing is with Threadripper, I don't think AMD is going to do a Threadripper unless Intel makes a return to HEDT. And when I say HEDT, that means high-end desktop. So for those of you who think the 13900K is a high-end desktop, you're terribly mistaken, because that's actually not considered a high-end desktop. That's considered a mainstream consumer desktop. And the same goes for the Ryzen 7000. None of these CPUs that I've been talking about are true high-end desktops. High-end desktop is Threadripper, and I'm not talking about Threadripper Pro. I'm talking about Threadripper, so the ones that don't exist anymore. And then Intel HEDT is what used to be X299 or Skylake X. That was the last Intel high-end desktop. When will the new Threadripper come out? I don't know. That's what I'm saying. So it'll depend on whether or not Intel does anything with HEDT. Now, the reason why it depends on Intel, and this is why competition works the way it does, because right now, the way things are with Threadripper Pro is if you want Threadripper, you have to basically step up to the tier above the high end. So if you guys think of like Dragon Ball Z references, so, you know, if a regular Ryzen CPU is just a regular like Goku with his black hair, you know, Super Saiyan 1 would be what? Like Threadripper. Super Saiyan 2 would be Threadripper Pro. That would be like the really, really expensive Threadripper. Super Saiyan 3 would be Epic. The server grade stuff. You know, that's like the pinnacle. So right now, the way AMD has allocated their wafers for their CPU manufacturing, they're trying to target the highest margin possible. And the way you do that is you sell servers. You sell Epic CPUs. You don't sell a bunch of, you know, Threadrippers or Ryzen CPUs. No, you want to try to sell as many Epic CPUs as you can. Now, obviously, you can't sell as many as like regular consumer desktop because, you know, the average Joe needs a laptop for school or work, or businesses need laptops for whatever. Hospitals need laptops for the nurses and the doctors. You know what I'm saying. It all makes sense. So the consumer desktop is still the vast majority of sales when it comes to CPUs. But the enterprise, the Epic CPUs, the Intel Xeon CPUs, that is where all the profit margins are. And if AMD can only get a specific amount of capacity from TSMC, you would want to sell as many EPYC processors as possible to maximize your profit margin. So that is the reason why we don't have Threadripper in the consumer market as it is today. Because AMD is better off selling EPYC CPUs to big companies like Amazon, Google, Facebook, the YouTube servers. How do you think all these videos of people live streaming on Twitch and YouTube, where do you think all this footage goes? It goes in a server that's either using an AMD EPYC processor, if it's in Amazon, which is basically Twitch, or it's going to like Google, which is typically going to be Intel Xeon, or now, more recently, the AMD EPYC servers. So these are the economics of what's happening behind the scenes that the average person who either complains about AMD or Intel or NVIDIA or something doesn't actually know anything about. So, like, the average person doesn't have any insight into any of this. So, that's the reason why you don't have an actual high-end desktop. I know it's a long-winded answer, but that's kind of the reason why. So, if Intel decides to come back to the high-end desktop, that will sort of force AMD to, come back also with a Threadripper. So I hope that answers that question, because that's a really good question, and the average tech enthusiast doesn't know anything about that. They just think it's Intel versus AMD all the time with like 13th gen versus Ryzen. Man, that's like a little kids fight at a playground versus what's actually happening with the big ammunition up there in the server world. So there's servers. Then there's workstations, then there's HEDT, and then there's consumer desktop. So for those wondering, this is EPYC. Did I spell it right? Yeah. That's EPYC. And that's the highest money. This is basically, this translates into, this implies money, big money. Then there's Threadripper Pro. That's the workstation. This implies money because this is expensive. Like the average person like you and me can't afford something like this. And then there's, because this is what? This is $100 per core. Think about that. It costs $100 per core for a Threadripper Pro. That means if you want to buy a 32 core Threadripper Pro, that's $3,200 just for the CPU. And everyone complaining about AM5 motherboards being so expensive. Well, a Threadripper Pro motherboard costs about $1,000. Maybe if you're lucky, you can get one for like $700 at Micro Center. So that's like the bargain bin model there, like $700 starting. So this is Threadripper as we know it in the past. So this is missing in action. And then we have Ryzen. So that is the product stack. We can do the same thing with Intel. Intel's basically Xeon, nothing. Well, okay. Intel's Xeon, and then for their workstations, they sell Xeon as a workstation because they don't actually have an HEDT platform anymore. And then they have nothing here, and then they have Intel Core, and that's basically it. So, and then, there you go. So that's kind of a business class lesson on how a semiconductor company operates in terms of the business case. So any more questions about that? Because I do kind of want to see Intel come back to the HEDT market. I feel like that would be really good for consumer desktop in general. So there's something beyond like a 13900K and a 7950X. But that's what it means to go beyond that, right? So like this is a Saiyan, this is a Super Saiyan, this is a Super Saiyan 2, and this is a Super Saiyan 3. But for this year, I think that compared to last year, this year is going to be a lot more boring, if you will, compared to last year in terms of product launches. I do think that there will be a 4080 Ti sometime this year. Now, I have no idea when. Probably in the second half of the year, NVIDIA might launch 4080 Ti. And it will, who knows what they decide to do. Like, maybe they'll drop the price of the 4080 to $1,000, and they'll price the 4080 Ti at $1,200, or maybe $1,300. Something like that, where it's like kind of like right between a 4080 and a 4090. So I can totally see NVIDIA doing that. I don't think AMD is going to really do a whole lot. Like, there's all these rumors about AMD has some big Navi 32 something, whatever. If that decides to come out, it's probably going to be like Q4 of 2023. So I expect this year to be the year of the mid-range and the budget. So like 7800 XT, 7800, maybe 7700 XT, and whatever NVIDIA decides to do. The 4060 is going to come out this year. Maybe a 4060 Ti. You know, those are probably going to come out. You got negative 40. I did. I don't think it was stable though. I did. I couldn't get level 5 to boot. But I did get negative 40. I could tell it wasn't stable though. There was definitely some kind of clock stretching going on. So I don't recommend it. Jimmy, yeah, with power bills, with everybody's power bills going through the roof. Yeah, this will be the year of more efficient graphics cards. So, like, those of you who look at Halo tier products like the 4090 or the 7900 XTX and are like, that stuff uses way too much power and it's way too much money. You know, obviously, forget about those GPUs because then they don't really matter. They're kind of irrelevant, especially if you're on a 1440p monitor. They're largely irrelevant in the grand scheme of things. This is going to be the year to upgrade if you're someone who typically doesn't pay more than $500 for a graphics card. I mean, just a few years ago, you know, most people only spent, you know, no more than $300 something on a graphics card. So this is going to be that year, I hope, at least, in the case of like 4060 and the 7700 or maybe the 7600 XT or whatever AMD decides to call it. Yeah, I think in most cases, negative 30 is kind of the maximum for most above average CPUs. Definitely, like in my case. So you guys want like this is what I'm running on right now. Like if you're curious, I'm streaming using a computer that's running with this. So I have a thermal limit to 80, so it doesn't go above 80 Celsius. This is what the V-core looks like at full load, and then it's a negative 20 offset, and that's my power draw. So that's what I'm running right now. I have to do a little bit more stability testing, but I figured the fact that I can stream and the PC's not crashing, and I have all this other stuff, I have these overlays running and all this other stuff, and I'm monitoring the chat and everything. The fact that it's stable so far, I think we're pretty good. Heard of undervolting the IOD? I've never bothered to do that. I know about that, but I haven't bothered to do it. Because I don't think... Honestly, I don't think there's anything to benefit from doing that. Because the IOD already doesn't really use a lot of power. It's already very low power relative to the cores. And I don't know. I just think that undervolting the IOD is more likely to cause things to it's going to introduce potential instability with the chipset. So for example, PCIe might get messed up by doing that or run into instability problems, especially if you have add-in cards on the motherboard that are plugged in further away from the socket. So for example, on a motherboard like if you have a standard ATX motherboard, You know, the CPU is typically here, and then you have your graphics card up here, and then you have like more PCIe slots down here and here. So if you undervolt the IOD, if you have something plugged in down here, you could run into instability with that device, like just flaking out on you and just blanking out, not appearing in Windows and that sort of stuff. So that's why I probably wouldn't do it. See, the thing about OCCT, though, OCCT is a constant load. Like, the thing with, in my opinion, I mean, that's a good test, but I feel like a better test would be playing an MMO. Because, like, an MMO is so, the behavior, the load on the CPU, the transient voltage spikes, and the dynamic, the fact that an MMO is very, very dynamic, the load changes so much and so quickly on a CPU, I feel like that, to me, is that's a better stability test than OCCT. Because OCCT is basically standard, like a full load to the cores, and it could be a thermal load too. Well, obviously it's going to end up with a heavy thermal load. But the thing with an MMO is you get way more transient voltage conditions where it sways up and down so fast. And if you're, like, for example, if you're running like a plus 100 or plus 200 megahertz clock offset above the max boost, like in my case right now, I'm running a plus 100 megahertz max CPU boost clock override on mine. And the thing is, OCCT wouldn't really show you instability with that clock bump. You would need something that's more lightly threaded, that has way more changes to voltage. And something like an MMO is more likely to show instability in that scenario. So, like, one of my things, I'll run, typically, I used to run Prime 95. I don't really use Prime 95 anymore. But I'll do, like, CPU-Z with the AVX 512 workload. I'll do Cinebench R23. I'll fire up Final Fantasy 14. I might run like a 3D Mark benchmark. That's a CPU benchmark. Or like the PCIe throughput test, just to see like if the core's talking through the chipset to the PCIe bandwidth, if that's going to be stable. Because those are the things too. Especially if you mess with B clock. Now in my case, I'm not doing anything with the external clock. But those are sort of the things that I would do to test for stability. Definitely an MMO game, though. Like, an MMO is one of the best stability tests. Because it's just so dynamic. Like, for example, Final Fantasy 14, just go to Limsa Lominsa, where there's, like, tons of other players constantly running in and out. That's going to cause so many transients on the CPU. That's probably one of the best tests that I can think of. That or New World or WoW, any of those type of games. Yeah, it does variable loads, but it's still very predictable. An MMO is way more dynamic and way more unpredictable for the CPU in terms of how it has to react. And MMOs also tend to be very CPU bound as well. Theoretically, if you can cool down the IOD better, you might be able to squeeze higher clocks out of the CCDs. Possibly. The thing is, though, you got to remember the IOD is kind of situated further away from the CCDs, because the way that the CPU looks, the socket is typically something like this, and then the way it's connected in the socket, it's like the two CCDs are typically right next to each other, Now I know this, I'm trying to draw this to scale, but it's not going to be exactly to scale. But you guys get the idea. They're kind of right next to each other. Then the IOD is kind of like up here, further away from them. So the fact that it's slightly more further away from them, I don't know. Maybe there is a gain in terms of better thermals if you undervolt it. But I just think that at the end of the day, you're introducing more variables for testing for instability than necessary. So I don't know. I tend to just leave it alone. Am I on the F8H BIOS? I am on... Yes. So for the Aorus Master, I am on F8H. So I'm on the Agisa 1004. And that's what part of this was. So basically, part of the topic of the stream was discussing Agisa 1004 because Gigabyte added a new feature. So basically, you guys see this level 1 through 5. This is that new feature on the Gigabyte Aorus Master. As of the new F8H BIOS, they've added a new feature that they call, and I kid you not, the name of the feature is Performance Bung. I don't know why they named it this. When I saw this as the name in the BIOS, I was like, what is this? What does this actually do, and what does this actually mean? I had to look up the definition of this word. Apparently, this is like... This thing is like, it's like a, what do you call it? It's one of those like almost like a sprocket or it's like it's like the thing when you're doing like EK water block hard tubing, like the quick disconnects, those little compression fittings. Apparently that's what a bung is, or it's kind of like that. I don't know why they named this feature that, but apparently Performance Bung from Gigabyte is a list of presets for thermal limits. You can specify 80, and then there's a level 1 through 5, where the level corresponds to a negative curve optimizer offset. So level 1 corresponds to negative 10, level 2 is negative 20, and so on. That's what Performance Bung is in this new Agisa 1004. So that's what that is. But yeah, that's what BIOS I'm on. And then on the other one, so the other test system that I have, which is the one with the 7700X, that one is on an older BIOS. I do that for control reasons, so I can see what actually changed. Because I was ranting earlier about the fact that the release notes for the BIOS doesn't actually talk about the new feature at all. It's ridiculous. You need to use that instead of manually setting the curve. No, you can manually set the curve. The only difference, so Performance Bung has it pre-configures these for you based off of whichever level you select. The thing is, so there's 3 different temperature settings. You can choose 90 Celsius, 80 Celsius, and 70 Celsius. And from those 3 temperatures, you get 5 levels of curve optimizer offsets. So for example, you can do 90 Celsius level 2, which means it will not exceed 90 Celsius, and it will also apply a negative 20, because it's level 2, it'll apply a negative 20 curve optimizer offset with PBO. That's what it does. And if you did 70 Celsius, it wouldn't exceed 70 Celsius. So it's a really good new feature for those who didn't like the whole 95 Celsius operating temperature at full load on all the cores. So I really do recommend trying the 80 Celsius setting, because I do feel like the 80 Celsius is a good trade-off between okay-ish temperature at full load, and you're still getting the benefits of the curve optimizer. Especially if you can do like a negative 30. If you can do negative 30 with 80C as the thermal limit, that's really good. In my opinion, that's very, very good, because you're going to be basically pulling more or less just 100 watts maximum, and the processor performs way better than if you were to simply just turn on eco mode. Because eco mode is going to give you the same power draw, but it won't perform as good. Why it was unstable? What was unstable? What was unstable? Are you asking why I think mine was unstable when it was at negative 40? I think negative 40 is just too little voltage for my processor. At negative 30, I'm not 100% sure. I need to fully stability test. I need to test negative 30 further before I say that it's 100% stable. Oh, you worked on the previous BIOS? I don't know. I would tell you, like, if you want to go back to the old BIOS, test it. But you really need to test a more dynamic workload. Because it could have been that on the previous BIOS, you tested OCCT and it was stable, but, you know, who knows? It might not be 100. It could have been like 98% stable, but, you know, if you go and fire up an MMO, then it ends up crashing after an hour or something. You know what I mean? Like, it may or may not have been 100% stable. I don't know. Maybe the newer BIOS is less aggressive with the voltage, and that might be a thing. So it reveals the instability more quickly. I don't know. I'm just kind of just throwing things out there that you might want to look into. Like, I would test with some kind of game that has a very... It can vary the workload on the CPU. So don't test some generic first-person shooter. Or don't test a game that's a GPU bottleneck type game. I don't think that will help. You definitely want to test a game that's CPU limited. So something like Civilization or Age of Empires 4... or Age of Empires 2 even, or maybe StarCraft 2, or, you know, any of those type of games if you don't have an MMO. But there's even, like, free-to-play MMOs. There's like Black Desert. There's a whole bunch of, like, free-to-play MMOs that you could test. In fact, I think 14 is free-to-play up till, like, level 50 or 60 or something. So, I mean, that's what I would do. Okay. Yeah, like I said, you know, maybe it's 98% stable. Like, it's so close. The other thing, too, you could try like negative 25 or negative 28 on the offset. You know, try something that's slightly less than the negative 30 offset and see if that helps. Because it could have been that you're very close to full stability, but it's just not quite there 100%. You had the 5950X. You're getting weird temp fluctuations when... Okay. Is this a processor issue or something? Does it happen with other things? Like if you try like a game or a benchmark or Cinebench or something... Like, you want to test more than just one thing to try to rule it out. See how it behaves with other non-browser based applications. That's what I would recommend. See if it behaves the same. I need to get some water. Gotta move this stuff out of the way. I got this wireless keyboard here for the 7700X. That's weird. How come? I mean, it's possible. It could be the BIOS. I don't know. Behaves fine, just otherwise. I don't know. When you say temperature, like what is the temperature actually? Like, what does it do? It goes from like 50 degrees to 70 degrees or something? Because I'm pretty sure, like, if you fire up a game, the game will probably do the same thing. In my mind, it seems kind of normal to me. Like, but I don't know what the temperature difference is. I mean, you just said temperature fluctuation. Like, what does that mean? You know, like, are you going from like 40 Celsius to 80 Celsius, 40 Celsius to 60 Celsius? But I mean, I think in terms of curve optimizer, like definitely, like this is the way to extract at best more performance, at worst the same performance, if not slightly worse performance than stock, but way better thermals and way less power. So it's strange because, you know, historically when you overclock a CPU, you typically get more performance, but you increase the power consumption and you increase the thermal. Now it seems like we're trying to do the opposite. Now we're trying to reduce the power, reduce the thermals, while trying to keep the same amount of performance, or in some cases get lucky and get more performance. But my only thing is I wish I had like another motherboard to test, or just like to review, like, or compare different results with, other than looking at like reviewers' data. But most of the reviewer data is from very old, you know, release day BIOS from September, and that's kind of irrelevant today. So it's kind of hard to find, like, for example, like I want to be able to compare the Gigabyte results with ASRock or MSI or Asus, you know, any of the other ones. Like, because I have just the Gigabyte motherboards, I'm only limited to a sample size of 2 CPUs and 2 Gigabyte motherboards. Ideally, I should be using 1 Gigabyte and one of some other motherboard vendor, like MSI or one of the others. But like I said earlier, for some reason, every time I go to Micro Center, Gigabyte is the only one that has the really good deals. Like, I wanted to get a B650E Asus, couldn't get it. They didn't have it. Gigabyte. I also wanted the Gigabyte one. They don't have that one. The ASRock Steel Legend, they didn't have that one. So, you know, I'm stuck getting Gigabyte again. So the only way I could differentiate it was, you know, upgrade one to a Giza 1004 and keep the other one on 1003 and test the, like, apply the same overclock and see if it's any different. And both CPUs can do the same -20, and in both cases they could do -30, but I don't know, I didn't really fully test -30 to see. I just kind of put -30 to see if I could boot in -30 and run a Cinebench run, and it was able to do it, but I didn't do anything else. $5.25? Are you talking about floppy drives? Or are you talking about CDs? What's a 5.25 disc? Is that a DVD? Or a CD? It's been so long, I forgot what is that. Are you talking about the floppy, or are you talking about the CD or the DVD, Blu-ray disc? I forgot. I think 5.25 is DVD, right? Yeah, you mean the floppy drive? What do you use the floppy? What do you use the 5 1/4 for? For what? Like, do modern PCs even are they even compatible with the card readers for those? What are those? What is that used for? For Windows 3.1? See, there's a USB floppy drive, but what do you use to read the 5 1/4-inch floppy drive? Because all the readers don't work with USB. So how would they connect? Like, you'd have to have a motherboard or something that is compatible with the interface that connects them to the PC. I don't even know what that interface is. It's obviously not USB, and it's obviously not going to be serial or parallel. I forgot what the old standards were. That's super random. Windows 3.1, but like how would you connect to the floppy disk? Oh, an Optimax parallel port. So it's parallel port. Okay. (1976) Secret Associates introduced the. Are you sure Windows 3.1 uses these? Because I know, like, Windows 3.1 would do the 3.5 inch. 3.1 was compatible with the old 5 1/4? Oh, you know what? Maybe they were. I'm pretty sure by the time Windows 98 rolled out, I'm pretty sure there was no 5 1/4 inch. Although there were still 3.5 inch. In fact, I think 3.5 inch continued to be a thing all the way until Windows XP. I don't think... Okay, no one really used 3.5 inch by the time Windows XP was retired. But up until, like, early 2000s, like like a lot of PCs in the early 2000s, they still had the 3.5 inch floppy drive. At least like a pre-build from like Dell or HP. But the 5 1/4 inch, like, that's the one where it's like, I don't know about that. That kind of, I guess Windows 95 was the last one that supported it. I don't even remember. That's like so long ago. And then because back then, like the CD-ROM essentially replaced the 5 1/4 as the main, like, spindle disk drive, but then you still had the 3 1/4 or the 3.5 inch. So the 3.5 inch was the A drive. The 5 1/4 was the B drive, and then you had, obviously, Windows was on the C drive, and then any kind of like D or E drive was typically where the CD-ROM went. H-Man, what is curve optimizer? You just got your setting, and I don't know what a curve optimizer is. Okay, we just finished talking about that. Let me go back. So basically, curve optimizer is a method that can be used. It is a tool used within the Ryzen, the BIOS on the motherboard, to lower thermal and power consumption while getting either the same amount of performance as stock, or slightly better performance, or in some rare cases with very, very good binned CPUs, better performance with less energy consumption. You need to play your daily turns on Space Quest? Man, that just made me think of how, like, today there are so many live service games, but you're making it sound like those are a thing that have existed forever. You have the Elite AX as well. Okay, so yeah, I'll just kind of give you a quick rundown using the AX as an example. So let's go over there. I think it's still up. Yeah. So here's the BIOS of the AX. So you can see, like, if we go back to F2, so this is the where's my mouse? So this is the X670 Aorus Elite AX. This is the BIOS. So F7A. So F7A is on AGISA 1003. So it's not the latest one. There is a newer one which has the 1004, which adds that feature that has that list of offsets. But this is basically it. So here's where you would enable Expo or XMP for the memory. You know, you can kind of see, like, things like the CPU temperature. Some people, for some reason, when I did this PC build, I got so many comments of people telling me that the thermal paste that I'm using, thermal paste has a shelf life of 2 years, and I need to use different thermal paste or whatever. But clearly, like, I don't need to, because this is already good enough. So the other thing is, there was a comment about, like, the fact that I literally put the little blob, the rice grain of thermal paste, and I didn't pre-spread it on the IHS. Now, the thing is, you don't have to do that. Like, you do not have to spread the thermal paste on the CPU before you mount the cooler. Like, when you put the cooler on, it'll automatically flatten and spread out the thermal paste naturally for optimal contact. So that's, again, something that's not really necessary. You can do it if you want, but you don't. I just think it's just messy and unnecessary myself. So and my temperatures, you know, have no problem. So I'm using really, really old thermal paste from, I think it's Cooler Master. It's probably like 4 or 5 years old in the tube, but it's working and I'm not having any problems, so I'm not going to do anything about it. I'm more of like you know, I'm not going to just waste thermal paste or throw it away and get, like, new ones just because people think that I need to change it. It's really good still. So KY Jelly's the best thermal paste. I don't even know what mine was. It was in, like, a tube. If you go watch that video, you'll see it's in an unmarked tube. It doesn't say Cooler Master, but I assume it was Cooler Master because it looks like the sort of thermal paste that would come with a Cooler Master air cooler. But essentially, so, like, this is what it would look like when you go into advanced. And then for the Expo, this is where you enable Expo if you're doing it from the advanced menu. But then the main thing with overclocking the CPU is going to be under advanced CPU settings. So here I've turned on SVM mode, so that's for virtualization. So if you want to run hardware assisted VMs or virtual machines, that's gonna be what that is. For some reason, I don't know why, but this setting is disabled on a lot of these DIY motherboards. I do not know why, because if you buy a laptop from Dell or Lenovo or HP, this setting is always enabled by default. I don't know why the, like, Gigabyte, Asus, ASRock, MS, I don't know why, like, a PC DIY motherboard has this setting disabled. It's really annoying to have to turn it on every time I update the BIOS. But here it is. So Precision Boost Overdrive. This is the main sub-menu, or I guess the tool set that you would use if you wanted to access things like the curve optimizer. So if we go in here, the default would be auto. You can disable it if you want it to run, like, pure stock and basically turn the PC into a pre-built from Dell. You would basically disable it. Or you can enable it, and then it will just use the fixed predefined values that that AMD or Gigabyte specifies, I guess. And then advanced is where we're gonna go to specify, like, manual settings. So you can specify PBO limits. This is where you would go if you wanted to enable eco mode. I did a video about that where you basically go in here and you can specify manual. And then in here, you can change these 3 values. But you will need to be precise with these 3. You can't just type in whatever you want. It won't be stable unless it's predetermined values off of a table that AMD has that determines like what is the correct TDP, which is basically the PPT limit. This is the power. This is the package power limit, and then you have your, what are they called? It's the thermal design current limit, and then there's the electronic design current limit. So these are both in milliamps, but again, like the motherboard might vary. So if you have like an Asus motherboard or an ASRock motherboard, it might be in watts instead of milliwatts for this one, and then this one will be in amps instead of milliamps. So it kind of depends on the motherboard. So you can kind of see the units are given there on the left. We're not really going to do manual because we're not doing that, so we're just going to leave that on auto. And then, but that's where you would go to enable eco mode. In fact, these numbers you see on screen, these are the numbers for eco mode for a 7700X and a 7600X. So these will limit the TDP to about 95 watts is what these 3 values equate to. So we go back to auto. Okay, so this is another one. So normally this feature is disabled, and normally this feature is disabled. So I'm just going to kind of make it look like how it would look if it was all auto. We'll just do that. So we'll just kind of go from scratch. So when you first go in here, it will look like this, I believe. Performance boost order will look like this. It'll just be auto. So what I've done is I've set it to advanced. And then what you can do here, so the CPU boost clock override, this allows you to specify a positive or negative value in megahertz. At least on Gigabyte, it's in megahertz. Now, for one of the others, it might be a different metric or a unit. I think it's going to be megahertz for all of them, though, because it wouldn't make sense for it to be in gigahertz or kilohertz. I mean, I don't think that would make sense. So you can do positive or negative. So if we say positive, you can specify a maximum number, a maximum value in megahertz that the CPU clock will boost above the maximum boost. So for example, if the processor can do 5.5 or let's say 5.4 gigahertz in the case of the 7700X. So that CPU, the maximum boost from the factory is 5.4. So if I say 100, that means in lightly threaded loads, it will actually go to 5.5. It will actually add 100 megahertz on top of the maximum boost. That's why it says maximum CPU boost clock override. Now, if I do negative, you have the so actually with negative you have like a lot more numbers, because you can actually, decrease the maximum boost by up to 1000 megahertz or 1 gigahertz. So someone might ask, why would you ever want to do this? Well, the answer to that comes with external clock generators and using the base clock to overclock. So for example, if you set the 100 megahertz reference clock to something like 105 or 102, that can cause your maximum boost to automatically increase by quite a lot. So you might need to come in here and back that down using the negative clock boost override to achieve a more predictable maximum boost clock. But since we're not doing anything with base clock, we're just going to go with positive. And positive, they allow you, at least with Gigabyte on this BIOS, it allows you to do up to plus 200 megahertz. So for example, going back to the example with the 7700X, that CPU tops out at 5.4. So with this 200, that would make this now run at 5.6. So now you're doing like 5.6 on the lightly threaded boost. So what I've done here is I've tested with 100, and so far it seems to be stable. running at 5.5. So that's what this equates to. And then now we move on to the, okay, so the next thing is the thermal throttle. So this is where if you don't like that 95C operating temperature, you can come in here and you can change this. You can set this to manual. And then here you can define an actual temperature number. So like, for example, if I don't want it to exceed 90 degrees Celsius, I can go in here and I can change that to 90 degrees. If I want it to not go above 80, which is what I had it, I can set it to 80. Some people might want it to go no higher than 70, and that's totally fine. They can do that. Just know that when you do this, the Zen 4 processors tend to hit their thermal limit a lot faster than the Zen 3 processors. So what this means is that the lower you go on the thermal throttle limit, the less boost performance you'll have. Because what will happen, like if we change it to 70, the processor will race to 70 Celsius, and then it will level off the clock at 70 Celsius. So I kind of think in my testing, 80 seems to be a good medium between like it running way too hot or it running, you know, not hot enough. So I kind of leave it at 80, but this depends on what you guys are comfortable with doing. Like some people might run it at 90. You can actually make this go up to 100 if you wanted. That means it'll go 5 degrees higher than the stock, which is 95. But, you know, I'm just going to leave it at 80. And then the graphics curve optimizer, this is basically if you want to overclock or undervolt the integrated graphics. So in here, you know, you can enable this. You can basically do the exact same thing. You can specify a negative or positive offset. So we're not really going to do anything with that because I don't really use the integrated graphics on here. So we're just going to leave that alone. And then the last tool in this list is the curve optimizer. And this is going to be where you basically do your undervolting or your overvolting if you're on like some exotic cooling, for example, or if you're going for like world records. So with here, you can do all cores, or you can do per core. But we're gonna keep this easy, so we're just gonna do all core, and then for the offset sign, you can do positive or negative. If I do a positive offset, that means that for any given frequency, I will give it more voltage than stock. So for example, if we do 10, I will add an offset of 10 at every point along that voltage frequency curve. So that is not what you do if you're undervolting. That is the opposite. This is basically overvolting to extract higher frequency. Now this only works, or you would only ever really do positive offset if you had exceptionally good cooling. Like if you're on LN2, this is something that people would do for like world record type overclocking, or you know, dried ice, or you know, a chiller or something like refrigerator. That's the sort of stuff where you would actually see a positive optimizer value. Like you wouldn't actually use this for every day. So what we want to do is a negative offset. We want to actually reduce the amount of power consumed while trying to maintain the either the stock performance, if not get slightly better performance than stock. So negative, and then this 10, this is going to be a number that determines the magnitude. So it says down here at the bottom, right? It says determines the magnitude of the curve shift to be made, entered in whole numbers. The larger the value entered, the larger the magnitude of the shift. So this is basically an offset value. I would recommend, if you're just starting out and you want to test for stability, I would recommend starting with 10. I think 10 is a good value that most CPUs can usually hit, although not every CPU can do a negative 10. Thanks for the live stream. Lots of good info. Are you going to head out? All right. Yep, thanks for stopping by. Yep, hope you learned something. So negative offset is basically what you're going to do. And then you can do 10. That's a good starting point. If you want to be more aggressive and figure out and try to get, like, if you want to simplify if you can be stable or not, I would start with 20. If you want to go really, really aggressive, you can also go with 30. Now, the reason why I don't like negative 30 to start is because not every CPU can do negative 30 successfully. Only better binned CPUs can achieve that. So, if you don't want to potentially have to recover from a crash, or the worst case scenario I've seen where you have to clear the CMOS because you can't get into Windows and the BIOS for some reason doesn't really post properly, that would be another reason why I would not recommend starting with 30, because it's going to be harder to achieve that one. So I would say 20 is the happy medium. Most CPUs can do 20. Almost all CPUs can do 10. So if you want to be safe to start out, you can start off with 10 and then see how it goes. Like, basically set this value, save this, boot into Windows, and then run something like Cinebench R23. Monitor your temperatures using something like Hardware Monitor or Hardware Info 64, and then just kind of see how it performs compared to the stock settings, compared to the temperature. Like, if you set it to 80, like in my case here, now with this setting, it will no longer exceed 80 degrees Celsius. So this definitely fixes the thermal thing that people didn't like, the whole 95C. So that's basically Curve Optimizer and Precision Boost Overdrive in a nutshell. But you're gonna want to test stability. So it's like, if you want to copy my settings, I don't have a problem with you copying my settings. I don't think these settings are anything crazy. Like, especially if you're just gonna do a negative 10 offset. I feel like pretty much 90% of the CPUs, if not higher than that, can do this. So just kind of, if you want to copy these down, that's totally fine. And then just try it out and see how it compares to stock. This is technically considered undervolting / overclocking, because essentially what we're doing is we're telling the CPU, so if we go back to the diagram that I drew out, we're telling the CPU for a given frequency. So like down here, if we call this on the curve 5.5 gigahertz, for a given frequency, if I apply a negative offset, so let's say my stock voltage in black was 1.37 volts. So let's say that was my stock voltage. To hit 5.5 gigahertz, I needed 1.37 volts for the CPU, for all core. Now, with the negative 10 offset, which I've applied, so if we want to draw that out, so you can kind of measure the difference here. The difference between here and here is what they consider a negative 10. We'll just say it's a negative 10 offset on the curve optimizer. Because remember, the curve is this curve. It's the voltage frequency curve. For every point on the curve, there is a specific frequency that maps to a specific voltage. So because we've applied a negative 10 offset, that might mean that now I only need 1.23 volts of electricity to hit the same 5.5 gigahertz. So you can see, the lower the voltage, that automatically means less electricity, less power, because power in watts equals voltage times current. So when you reduce the voltage, automatically you're going to reduce the power. And what does that also mean? That also means that you're going to reduce the thermals. You're going to reduce the temperature, because there's less voltage, less power means less heat. So that is the concept of using the curve optimizer to further optimize the CPU and essentially hit the same or better frequency performance, better frequency response at less voltage. So that's the whole concept behind this. That's what we're doing here. So with that, I think that's pretty much going to be it for the stream. That's basically all I wanted to cover. I mean, I think I got the concept across. Definitely, I recommend people try out a Giza 1004. I know it's out on Gigabyte. I think it's also out on MSI. I think Asus has 1004 as well. Let me see. Where's my browser again? Let me see. Let's look up Asus real quick. Where is it? Driver, firmware. Okay, Asus still doesn't have it. At least not for the Crosshair Hero. So if we look here, I'm looking at the ROG Crosshair X670E Hero. This is kind of like the flagship motherboard from Asus. It looks like Asus is still on 1003, so they're not going to have that that newer preset list that you can select from for a specific temperature that equates to a specific curve optimizer setting. So that's unfortunate. They're a little bit behind. I would have expected Asus to be a little bit further ahead, but you guys can see the Aorus Master does have the Giza 1004. If we check MSI X670E Ace, I always tend to just pull up these because even though these are the really expensive ones, pretty much if these don't have it, then you can assume that the other boards don't have it. So MSI does have it. A Giza has 1004, so MSI's got it. So if you've got an MSI board, you probably are in luck. So it looks like Gigabyte and MSI, and then the last one to look up is ASRock. BIOS. They also have it. So it looks like Asus is the only one that doesn't have it for some reason, unless it's just this particular motherboard. That's really surprising. That Asus, the largest motherboard vendor, is actually the one that's behind in terms of BIOS updates. That's really interesting to see. So anyway, guys, that's probably going to be it for the stream. Are there any final questions on anything on PBO, which is Precision Boost Overdrive, or Curve Optimizer? Or anything that we talked about here in general? Because I will say that I do think that AM5 is maturing nicely compared to how it was at release. We have much more stable BIOSes in terms of memory. Overclocking is way more stable now. I remember at release, some Expo profiles would fail to even run properly. So we've kind of moved beyond that. So the early adopter days are starting to get behind us now, which is really, really good moving into 2023. That means that when that X3D chip shows up later this year, it'll probably be very, very successful because the platform will have received enough Giza updates by that time that anyone who wants to upgrade to like a 7800 X3D, for example, and pair that up with either a B650E or an X670E or X670 motherboard or whatever, they're probably not going to have nearly as many of the weird early adopter quirks that accompany this platform at launch, usually around like memory compatibility. That was probably the biggest thing that I can remember at launch. All right. Well, I mean, we have like it shows YouTube is showing we got like 16 viewers, but no one has any questions. So I guess with that, we're probably gonna go ahead and end the stream. Once again, guys, thank you all for watching and tuning in. I hope you guys got something out of this in terms of info on how to use Curve Optimizer. If you're curious about how it works and you know what it actually does, what does the curve actually mean? What does it look like? Hopefully this was useful in some way. And with that being said, I'm going to go ahead and get on out of here. And once again, thanks for watching. And I will catch you guys in the next stream. Thanks.